So welcome once again, and we shall be starting with the webinar. So just a quick thing, let me first quickly introduce myself. I would be the speaker for this webinar. I am a certified SAS data scientist. I have been working with SAS India for quite some time, around 15 years, and I have involved myself in data science risk solution enablements. Of course, there are other roles as well in SAS. Now, I think let's jump into the topic and we would begin. And few things before we start. Well, in case you have any query or questions, please feel free to put them in the chat. We would be addressing them kind of twice. We'll divide the session into two parts. In the first part, we will discuss some of the theory and the logics behind SAS and open source integration, and then later on we will do the demo. So twice I would address the questions to any answers to any questions that would be there in the chat. So please feel free to type in. Well, to begin with, we might want to start with some basic ideas on SAS Via. Well, so SAS Via here is a platform which is cloud enabled. It has got lots of capabilities. We will explore a bit around it. However, this is the name of the platform on which SAS products are now hosted. Traditionally, SAS has also been there on traditional basis where you get to install the system and it becomes a local system on your PC or on a server. Nevertheless, in the age of cloud, SAS also offers cloud offerings, and all of them they come on a single platform called SAS Via. And SAS Via is something that supports all the tools that are necessary for the analytics lifecycle, wherein you need to ask questions or problem statements depending on your nature of the business or the requirements. These questions might change. For example, if you belong to let's say a telecom company or a company which is into dealing with mass customers, you might want to ask questions. For example, why there are certain customers which are churning away, or it could be any other question. For example, why revenue is down, or what kind of customer buy the product. So as I said, these questions could be endless, but the answer needs to be sought through data. So wherein the platform tools available on SAS Via enables you to explore the data that might be answering your questions. And sometimes data exploration reveals that a lot of data preparation activities needs to be done. And likewise, you might want end up creating models to answer your question. For example, if the question was why customers are churning away, you need to look at who are all the people who are churning, what are their characteristics, how they compare with the people who are not churning. And then likewise, you need to prepare data, your analytical based table, where you want to fit models so that you have a prediction model, and then that model could be deployed to answer your questions. And that's where the implement part would come in. So you see, this cycle goes on wherein you start from asking the question, exploring your data and answers, preparing the data accordingly, putting model into an action, and then you end up implementing the model, and then you act on it. For example, a typical model that might want to predict churn, or let us say if you are a bank, you might want to see what kind of people are at risk of default. So the model is there, you have implemented, and then you have to act on the model, wherein once predicted based on the model that these people might churn away or default, what actions could be taken up. And then you need to evaluate all the activity where what worked, what do not work. It will actually involve a lot of evaluations around your model, their results. And likewise, the cycle continues and you will refine your questions that you ask, and this becomes an activity which keeps going on and on. So SAS Via products are supposedly be actually supporting all these activities through various tools that SAS Via holds. Now, that's a bit brief on SAS Via to begin with. And when it comes to the SAS Via tools, they're all consolidated at what we call a SAS drive. And from there, there could be a SAS studio, which would be the programming interface where you end up writing codes It supports SAS language. There are procedures available to incorporate Python or R, both in the traditional sense or otherwise. Now, this is just one of the tools for programming. We do have visual analytics, which allows you to explore the data, make dashboards, tell your story. The tool could also not only be used for the initial exploration of the data, but it could also be used for final showcasing of the data through a dashboard, be it for the monitoring purposes or for indicating outcomes of a model that might influence managers or the top management to take right decisions. We do have Data Studio, wherein it has all the features which you would love to extract, transform, and load the data. Again, this tool is all point and click. So SAS Visual Analytics, SAS Data Studio, they are all point and click. Nevertheless, the coding could also be done using SAS Studio. Likewise, within Data Studio also, you're free to write queries. Then comes, the list of tools which allows you to do modern day machine learning or statistics, or let us say requirements of your forecasting could be met by different SAS tools like SAS Visual Forecasting or SAS Visual Data Mining and Machine Learning. Likewise, once the models are created, as I said, if you look at the entire analytical life cycle, the list of products that you see, you start with the data, explore the data, prepare the data using Data Studio, build all the models using SAS Visual Forecasting, data mining or statistics, and then monitor models through SAS Model Manager. And then, you have Environment Manager, which is another tool which allows you to ensure that all the servers, all the access rights are maintained well. And then finally, there are other tools as well, wherein they can be added depending on the requirement. It could be a specific credit risk solution, for example, in a bank, or it could be a customer intelligence solution for a marketing team. So those are specialized tools doing one activity or the other. But this entire gamut of tools is what we call products within the SAS via, and each of them have got a purpose to exist and applications in the entire analyticals life cycle. Well, so having said so, the analytics life cycle is supported of the journey from the data to the final results, incorporating all these steps in between: data exploration, modeling, then implementing and monitoring the models, and then taking decisions. SAS via is also available in cloud, as I said, and in the cloud, the likewise benefit comes that is scalable. So your via can work on a grid of systems, and that grid could be simply extended by adding more computing elements or computers to your grid. And all the processing that SAS via does is in memory. So the data is persistent in memory. That actually helps you to speed up the processing. Not only that, you have the benefit of parallel processing, but all the data is in memory. And all sorts of users can actually come in their own capacity and authorization and perform the activities that are required to carry out an analytical objective, or so to say, the entire activities of analytical life cycle can be spread across various users within their skills and capacity. They can come and contribute. Well, so the old SAS 9 or the traditional SAS 9 version, all those capabilities are also there. So we just happen to give the name SAS Compute Server, and whatever happens on SAS via, the name that we provide is Cloud Analytic Services, or simply put CAS. That's the abbreviation we will use in this webinar quite a lot, just to refer to the entire activities or set of services that we utilize on SAS via platform. We'll call it CAS. So let's call this one as traditional SAS. Let's call this as parallel processing engine or new age cloud-based environment. We are calling it CAS. So CAS is the backbone of SAS via platform. Now, of course, to fetch any of these tools, we are going to use browsers, and through those browsers, all the authorized persons can actually access any tool they wish to and perform activities that they need to do. And the benefit that we will realize is that you are kind of free in terms of choosing how you want to interact with SAS via, or let us say CAS in specific, the cloud analytics services. So there are provisions made that not only your SAS knowledge is useful, but over and above, you might be a Python user or R users or maybe Java or Lua. So these languages are also supported to interact with the CAS server. And that's where the element of SAS and open source integration comes into the play. We are going to dig deep more in this webinar, but these are some beginning items that we should understand which platform in SAS, that is SAS via. We are interacting with cloud services, so we're going to call it cloud analytical services or CAS, for example, here. And then, using browsers, we might want to interact with the CAS here. So having said so, before we get into all the SAS via related items that we have got, we must understand that interaction with open source is not a new idea within the SAS. If you just see the timelines, for example, SAS software started somewhere in 1976, wherein it was all SAS programming native language that was there. And early 90s, if I may say so, was the time when R and the Python and open source was born, and then it became popular. And as the time passed, we all know the usage of open source in the analytics domain has been quite rising. And likewise, during that time, even in the traditional SAS, the base SAS, which is one of the programming interface in SAS that is there and has existed, and probably that is the longest that I've seen. It would also apply or allow you to execute open source code, of course, using system commands, and then there is a data step to it, which means through programming, there was a possibility within the traditional SAS as well to interact with your data through open source and SAS together. So it's all like, you've got capabilities within SAS, you want to use that. And similarly, you've got something on Python, you could merge the capabilities and take the benefits of both the proprietary as well as the open source world. In fact, SAS has a procedure or a package called interactive matrix language. Now, this one is pretty fundamental to perform any activities which uses matrix algebra. And the moment I say matrix algebra, it actually covers almost everything. If you look at how the statistical calculations are performed, especially when you have an n-dimensional data, so you need matrix algebra for that. So SAS IML products have existed pretty much as good as baseline has existed, and that procedure or that product also supports SAS code. And from within the SAS code of IML, you could also submit R codes as well. Well, so there also, interactions with open source have happened. Similarly, we have another product called Enterprise Miner. Maybe some of you have heard these names before. SAS Enterprise Miner was a point and click, and in fact is a point and click tool within the SAS 9, or the traditional SAS as we call it. And over and above that, it actually has an open source node where it gives the luxury of executing the R code from a particular node called open source integration node. And as well, you could simply run your Python codes as well. And then, the focus today, of course, is what we are going to talk at length is the SAS via. That's the new platform I was talking earlier. And here we have, once again, integration with open source. So the point I want to make that interaction or integration with open source and SAS, it's not a new concept. It has existed quite a number of years now with the traditional SAS products like base SAS or SAS IML or SAS Enterprise Miner. And in the modern world, the platform of SAS via also simply enables the same thing. Focus of the webinar obviously would be to talk about SAS wire thing and traditional thing. You might find a lot of resources probably towards the end. I would share a few things where you can read more about either integration with SAS via or else with the old products. In fact, our SAS website has got a lot of tutorials, a lot of things that showcase how these interactions are possible. Nevertheless, let's move a bit. Now, when it comes to SAS and open source, remember that in the modern day, we need to still take care of our data. There are computer vision algorithms that are working and pretty much useful in the modern day world, be it, operationalizing of the models or performing forecasting or let's say optimization requirements or IoT analytics or for example, intelligent decisioning. Now, all these areas, we have full-fledged SaaS packages, and then as well, there is an opportunity in all of these areas to interact through open source as well. So to say, what gets covered when we say SaaS and open source integration, I would say it's pretty much everything that the modern world needs. Now, of course, we need to also understand why this integration might be required. We'll be discussing it at a certain point of time during the webinar, but the coverage areas, as you could see, are pretty extensive. Now, SAS via and open source, we need to talk a bit here that why such a feature is desirable and why it should exist. Few things, for example, in the modern day world, if you look at organizations, they would have host of tools available to them. There might be multiple teams. They might be acquiring companies who were on open source, or they would have a new initiative which works on the open source. Well, and then they might have, for example, SAS working for them. And quite a number of times, SAS becomes a requirement to be used because of the regulations wherein the open source might not be used or absence of products. For example, in banking, we have anti-money laundering solutions where there are products which are all proprietary. There's hardly any open source used over there because things are at a very high stake. So SAS anti-money laundering, as I was talking about, it's all about having mechanisms and systems that can track any money laundering activity in a bank, and every country has got regulations for it, and also you need proprietary softwares over there. However, let us say there are a lot of things that you want to do, so you might have SAS already there with you. You are already a SAS customer, but there are certain new initiatives, maybe experimental analytics, or you made an acquisition or acquired a company which is on open source. So you want to see best of both the worlds. So SAS via along with open source would provide you with such kind of flexibility, wherein if you have Python programmers or skills in Python or maybe R, well, you could use simply SAS to run and execute those codes. So it actually brings everything in sync. Again, SAS via and open source might be helpful because it breeds innovation. We understand that there are a lot of new packages keeps on coming in R and Python, and your teams would like to explore them. And on the same side, SAS, for example, as proprietary, would also be coming up with newer products or newer ideas, or for example, newer capabilities. So a gel of both would actually, we believe, promote innovation, wherein you could see best of the innovations in both the worlds and then incorporate into a single platform. Plus, quite a number of times, automation of several activities in SAS is quite easy. Those who have used SAS, I would say, we have machine learning through pipelines. There also, you could add a node with your open source, and you could take the power of automation of SAS and marry it with flexibility that you get with open source. So you could have once again a feature leveraged for your success. Similarly, SAS tools comes with a lot of governance capabilities that are there, especially in regulated industries where governance and compliance is a must. And then, there are a lot of requirements over there. So for example, we have products like SAS model risk management or any other risk management tool which is used by highly regulated industries, banking, insurance, and so on. So you want to take the benefit of SAS governance. At the same time, you want to keep flexibility of open source, so you got both of them there. Similarly, the scalability aspects that SAS via platform provides, you want to leverage that as well. So likewise, at the same time, keeping the capability of operating in open source. So there can be different reasons for different set of people going for such kind of an integration, but they're always on the advantageous side, as the idea of SAS via and open source integration is to simply provide best of both the worlds that is there. Now, a few more things we need to talk about. See, you could be using Python IDE, you could be using a Jupyter notebook, and that could be your client. And what we have in SAS via is CAS server. And all you wish to do is to, can I actually trigger actions on CAS server through the open source? And that is what, the underlying theme of SAS and open source integration. Well, the answer is yes. You could pretty much do that while sticking to the structure and syntax of your open source. You actually, give commands to CAS, and then you get the results back. Now, of course, we would also try to understand why this should happen at the first place, why I'm not using Python directly, why I need to send things to the CAS server and then get back the results and then probably once again analyze them on Python. Well, we will showcase it through a demo, and we will also be discussing in the first half of the session that we have. Well, so having said so, first of all, let's talk a bit more on CAS or Cloud Analytical Services. Basically, it's the CAS server, just a name given to the collection of machines that are controlled by a controller, and there are worker nodes. And you could add as many as worker nodes depending on the requirement. So CAS server, as we speak, within SAS via is based on parallel processing principles, and this model is totally extensible and scalable. The controller is the one that would actually be taking care of identifying the data sources, and linking up with those data sources, the types of data sources. The list is really, really long. Pretty much any type of data is what SAS via can link up with, be it your flat files or Hadoop or any kind of database. It allows you to link, and then the data gets distributed based on the logic within the controller in an optimized manner automatically over the worker nodes, and the data would persist in memory. So in the beginning, I was talking about in-memory processes or in-memory data processing. That is what is supported by the CAS server. You have all the rights to actually, connect to the system, drop some table, all those would be there. And different workers actually can, or users can access the data. In fact, the same table also can be accessed by different people. So to say, a single set of table could be used by three different users. Now, one user might want to create a report out of it using SAS Visual Analytics. The other one wants to run machine learning models. All can happen parallelly, and that's the beauty here of CAS server. And all the data processing that happens, it all happens on parallel basis. This is what the parallel processing we have been talking about. And the results, again, the controller is the one whose responsibility is to ensure that the data that is distributed parallelly, the computations do happen parallelly, and the results are collated, compiled, or summarized. And then, of course, the controller will communicate with the client, and the results are back to the client. Well, that's a kind of mechanism that the CAS server would hold. And then, the controller allows you to save the table on the grid or on a hard disk, or if you wish, the table should come to the client. Now, of course, here we are talking about tables that are summarized ones and the smaller tables that you can use on your client system. Now, that is possible. So uploading to the server, downloading from the server, all these possibilities exist. And the two, of course, you might be triggering commands through a Jupyter notebook using a Python or Python-like syntax. Well, the CAS, the benefit of having CAS at the back end is the parallel processing, which is maximized here, and it's all in memory. So there is a lot of time saved avoiding input and output or writing files to the disk. Well, so the CAS server can connect to any kind of data sources. As I was earlier telling, it could be a database, Hadoop, or even streaming data. We call that event streaming data, or for simplicity, let's call it IoT data, where the data, maybe within fraction of seconds it gets updated or changes. Typically that happens in the IoT applications. We can connect. You could actually connect to a path with a set of files, or the data could itself be on the cloud. And the CAS actions are the one that are gonna work on each of the worker nodes, depending on the commands and the analysis you need, which could simply mean that either you simply want to wrangle with your data, you want to manage and prepare the data, or you want to run and put models to work. It could be done. Also supports SAS data steps, and then the SQL, which we are now calling Fed SQL. So all these procedures and capabilities do exist. So for CAS, within the SAS world, we have a programming language. Now, those who are well conversant with traditional SAS, they would understand that we have base SAS programming, and then there is a provision of running SQL codes through procedure SQL or SQL. Then you have other capabilities within SAS world, like SAS macro language or SAS component language, and hence and so forth. Here, when we talk about CAS, it's similar kind of a language, but meant to be working on a cloud analytical environment, and we call it CAS language or CASL. That is the language that it understands. Nevertheless, through APIs, you are actually free. So if you want, you've got options. For example, I want to directly interact with all this CAS server. I want to run CAS actions, which can include pretty much anything. I got a language here called Cloud Analytic Services language, or else you could still stick and might say, oh, just want to use my knowledge of SAS or SAS codes, or else I want to use Python, R, Lua, or anything. And then, of course, through APIs, the system actually allows you to interact with CAS. So you see that we got functionalities and capabilities, and that's where the open source integration comes into play when you're looking for actually doing work on CAS server, but this time using maybe a Jupyter notebook, and that too via Python or maybe R. Well, all the applications on the user interface of SAS via, whether we got a list earlier, we have SAS visual analytics or text analytics or machine learning, or now these are all the applications doing different things, as the names also suggest. For example, SAS visual forecasting largely would mean a point and click approach to perform forecasting, or for example, SAS optimization, which would be used for running your linear programming or goal programming and other kind of activities that are there. Or SAS customer intelligence is the solution for customer intelligence. So all of them, they would also directly can interact with CAS. Nevertheless, within each of them, you might want to have some Python-based code. Those possibilities of integration are also there. Well, so that's pretty much the idea. Now, see, the benefits we have seen already, just to summarize. Since CAS is one of the big things that lies at the heart of SAS, and then the open source can be used to interact with this. So we are just looking some of the capabilities, and we have talked about them, and we just summarize here that first of all, the CAS server, the benefit is the data persists in memory. It reduces input output time for writing files in and out through the disk. So that's one of the benefits. Second is got parallel processing, and multiple users can access the copy of the data and they can parallelly do activities. So it speeds up the activities of analytics life cycle. And then, of course, a variety of applications are supported on CAS server. Now, having just introduced and I have just spoken about CAS server, we still further go on. Now, when it comes to interactions, so let us say you got a Jupyter notebook, you got some Python-like code, you want to actually execute CAS action, pretty much is possible. And then, you can actually have results back going to the Python, and then you're free to analyze further. Once again, all sorts of tables or the data types are supported. So whether it is a data frame or any numeric array, or let's say a character array, or any kind of data with variables, numeric and character are supported. Of course, several other data forms are also there, but largely this is what is mentioned. Now, CAS would work in form of action sets. So it's a bit on CAS language. So, just like your Python has got packages, CAS actions also got packages. And then, actions are nothing but the methods. So you might have an action set, let's say table, and then to analyze that table, you would have methods available. The table is just an example of an action set, and you want to fetch some of the rows, you want to get the file info, or you want to get the table info, or you want to see where the table rests in the CAS library. So that is called CAS lib info. These are just an example of that. So likewise, we got action sets for deep learning, computer vision, machine learning, forecasting, sampling, and so forth. So everything in CAS works on actions and action sets. Action is just one particular activity that you can do in a given action set. So if the table were to be the action set, these are some of the examples of actions that you can take. So usually action set dot action name is how the command would go or the entry would go in a CAS language programming line. Now here is an example of a typical action set that you might want to use in CAS language. So you want to say table.fetch. So this is the action set, and this is the name of a specific activity or action that you want to take, or a method of fetch. And then you want to specify, okay, this table name from this library. So the concept of library is just the same as traditional SAS. So you need to just assign library. So it's just an example, and then it fetches this table cars and it brings in the top 10 rows. You don't want to index the data. So that is also again, very specific syntax here, but then structure would look like this. So you have action set, you have an action of fetch, you got parameters within that action, and there is a whole entire help documentation available out there on our SAS documentation page, which if you wish, you can learn more or explore more. And then there are subparameters. So this is typically how the CAS language action and action sets would look like. Now, a few things to compare it with Python. See, SAS, if you know already, probably you've used base SAS programming and many other kinds of programming languages. See, certain programs tends to be case sensitive. For example, Python is a case sensitive language, but in SAS you don't have that restriction. You're free to actually use any case you want, and there is no restriction in terms of the indentation or whether the code should be spread across multiple lines or in a single line. So it's more of a free flow language, just like base as if you have used already. So these are some of the activities or the characteristics that are there. So any of these actions, what they do is whenever you actually push a CAS action to the system, an instance of that action is created, and then all the other things are done. So in fact, You could have multiple actions working on the same set of table. Each of them would be independently handled, and thanks to the controller parallel processing and the design of the cache server. So simultaneously and parallelly, several of different users, they might be actually triggering different types of cache actions on the cache server, and all they're getting their results based on what action they have called for. So now a few things. Yes, we could use Python plus cache server as we have called in, but let us see that, under what circumstances this open source integration might be benefit. Now, to understand this, will cache server will always be helpful, whether it is always faster. See, the whole idea here that what we want to do is the flexibility of the open source language and all the benefits of cache server that I have described since morning. You want to leverage that. Now, this kind of an integration would be justified under specific circumstances. So you say that, the cache server is fast and everything is there, but then, the integration activities, there should be a justification for doing such an activity. Now, for example, the cache itself would take time to start the services. Of course, probably as an end user, you're not worried about this. And once started, they are available 24/7. But initially, there's some time that, the cache server will take. The initial loading of the data might once again take time. And then, you want to monitor. So there are overheads and there are activities that needs to be done. For example, loading the data, monitoring the data processing, collating the results and everything, and then delivering results to the client. Now, all these activities, they're justified when you are dealing with very heavy data sets. So let us say if you have data with only few rows, then you might not want to use cache server. See, if it's a small table, maybe a few hundred or thousand rows, then what simply happens is you use the client, use your open source, use all the native packages of Python, and you finish it then and there. See, there are certain specific circumstances where we justify this kind of an integration. One of the things could be that, you are working on a data set which is really, really huge, maybe, let's say transactions on a stock market for several months, or IoT data of certain thing. You're doing a fraud model and you want to run the data for several weeks or days of worth of data. So your data actually is running into huge sizes. We're talking about gigs and gigs, or sometimes terabytes of data as well. Now, all that timings that cache will take would eventually be justified by processing that large amount data very much faster as compared to any traditional system. And that's where, the cache server advantages will come. So we need to just understand that the process is listed over here. It takes time. If your data is really, really small, then you need not do all of it. You simply do in the traditional way or only a simple client system, and you're free to use whatever tool method you want to use. These things are justified when you undertake all these activities, and these activities, whatever time they might take, of course, it doesn't take a lot of time to perform all of it, but the point here I want to make is that these all would be done, and this would only get justified when you have loads of data with you. So where I should be using cache, if I've got, let's say, both open source with me, I'm free to use Python on my client. And then, of course, I got access to the cache server. So as I said, this open source integration or usage of cache in general is justified when your data sources are too big data here we're talking about. They're too larger than, let's say, your client machine could handle, or of course, you got your big servers and all, but the execution time and speeds are something that you don't want. That's where, the cache or the utilization of cache will be justified. So large data, sometimes you have multitude of things. Not only that, your data is huge, but the logic in the code or the code that we are running, for example, there are machine learning algorithms which needs multiple passes through the data. For example, a deep learning network or a neural network, or even a forecasting algorithm like ARIMA, the auto regressive integrated moving average. It has to actually pass through the data multiple times. And any traditional system there would take a lot of time to process it. So these are all examples where you have a long running code, and that's where you want to come to CAS to cut down all that time. So that's where you might want to use. Similarly, any computationally demanding processes. So obviously, long running code might still be long because you want to do a lot of activities, but they're not very computationally intensive. But at the same time, you might have a complex algorithm that would require a lot of complex calculations. So all the examples I was giving, ARIMA or let us say neural networks or deep learning, they also have a lot of computations required. And then of course, you want to use CAS because there's another SAS-Y application that depends on that data. So one way or the other, you have to actually end up doing work on CAS. So there are these reasons, largely speaking, you would end up actually interacting with CAS. And of course, interaction with CAS, whether it is CAS language or open source language, there has to be a justification so that you can reap the benefits of the CAS server. Likewise, sometimes there are limitations to what kind of tables or data can be read in a specific software. For example, Python can handle a variety of tools. There are a lot of packages, but still, there are data forms, there are certain types, certain streaming data types, for example, where you might not find that Python doesn't have any interface or something. But CAS actually tends to provide a lot of those things. Now, your CAS can read the table and process it faster. Python doesn't have the capability, so somehow I can leverage the capabilities of CAS, the benefits of CAS, at the same time, using the knowledge of Python that I have. So these are the situations where the justification should exist for usage of CAS. And quite a number of times in large organizations with our clients as well, we have found the integration way or open source and SAS working together because of each of them has got their own benefits in their own sense. So that's how these are used. So a few things, for example, uh, you want to process data on the CAS server. You want to have the CAS table. Sometimes you want to bring it back to your client. So this could be a possible scenario. Or you want to simply upload the CAS using other applications. This all is possible. So whether it is processing or simply bringing back the data to your client or uploading the data to CAS, all activities are supported. Now, first of all, we must understand that through Python, you can trigger CAS actions. You can explore, prepare, analyze, model big data in CAS. Now, once again, Python happens to be an example. You can put any other open source language over there. You could put Lua, R, Java, for example. And if not all these, the SAS languages are always there. You have your CAS language, the CAS programming. You independently could also execute CAS actions. Now, this is over and above what SAS can already do. Here, you could think of any other open source as well, be it Python, be it R, Lua, or Java, as I said. So all this gets possible. So then once, through Python, you have loaded the data, the rest is what needs to be done, whether the data needs to be consumed by any of the SAS-Y applications or other team members want to use them for their own purposes, everything is possible. And then, you might want to call in, maybe, you have just analyzed or modeled some data, the results are there, and those results are usually summarized tables. For example, you have executed a neural network, and then, you just want to see the parameters, or you just want to, look at the model performance. So all those tables are usually summarized in pretty much small. And then, you want to still use the capabilities of your Python open source. You might already have a code which generates, let us say, ROC charts or lift charts. So you want to leverage that. So what happens here is all the heavy work computations are done by CAS, and your regular work for that, you might have codes already existing. You can leverage that as well. So it is like best of the both worlds that you want to, or the advantage that you want to take. Well, having said so, you could actually, copy the tables in and out without a doubt, and then keep on processing. So in fact, here also, once we say that, the table is going back after doing anything, a smaller table it can be brought in back as a data frame and you're free to use it. Or else, you have a data on the client and then you want to put it on the cache server, you can pretty much do it, and then it can be further utilized by other SAS applications and team members. So all the possible scenarios do exist. Now, whether or not which scenario becomes useful and handy or more applicable at your site, it will depend on the requirements. But possibilities of in and out of cache, getting the calculations and analysis done on cache and bringing back to the client, let us say all using through a R or a Python interface. All these three activities and scenarios are pretty much possible. So that's how it behaves. So you actually end up using whatever is the best tool to do an activity. Quite a number of times what happens is, we have seen that, a lot of clients, they acquire companies. There are a lot of Python code already lying over there. But of course, the processing now, for example, let's say, you have merged or acquired a company, they become integral to that, and your data sizes have become huge. You already have a cache server in place and your processing happens over there. So you want to assimilate and integrate all the new analytical cap all the analytical capabilities which are new to you now by the virtue of acquiring that company. So one way could have been to actually, let us talk about if there was no integration, then there is a Herculean task to actually convert all that Python code to SAS first, and then all the Python skills that the company that gets acquired, then what to do with them. But with integration, what happens is, the people who know Python, they still remain. Their codes that have been written, they're still there. Only thing for the processing part and reducing time, taking the advantage of scalability and parallel processing, we bring in cache. So the idea is we end up using whatever is the best tool for the job, we deploy that. So integration actually helps in achieving this portion. Well, so now what I would do is I would go in a bit of a detail and of how you want to interact with the package or with the cache server. Now, we all understand that whether it is R or Python, for example, there are packages in R, packages in Python, and these are some of the packages that are there. Now, I want to actually interact with cache server, how it will be possible. Now, one must understand first that directly the native Python packages would not execute in cache. And you can imagine the number of packages that Python has. And those packages, or let us say R for that matter, these packages would eventually be actually, getting updated more and more, and new packages will come. So, and since it's being an open source, a number of packages grow very, very rapidly. Some of the packages become redundant, new versions come. So there's a lot of activity happening in open source at any given point of time. But then can, cache server take all of them? The answer is no. So if the answer is no, then what integration are we talking about? That's certain things that we now need to understand here. So first is, we know that native Python packages won't execute in cache. So what can be done is a SWOT package. Now, the name SWAT, of course, it's a package that is available. You can, simply install it in Python, and then, you are ready to interact with cache server. So there is a package. SWOT would be, the full form is a scripting wrapper for analytic transfer. You need a package to begin with. SWOT. It's a scripting wrapper. I'll just explain, and later on we'll demo it as well. The scripting wrapper for analytics transfer is, we are abbreviating it as SWOT. Now, what the SWOT enables us is to actually interact with cache server, and eventually, it kind of translates your requirements or your code of Python into something that cache can understand. Wherein we talked about earlier that cache can understand actions and cache methods. We took an example earlier. And then SWOT package is something that would allow me to interact with cache server via Python, for example. Similarly, we have got SWOT package for R, and likewise, there are other packages. So what SWOT package does, for example, the pandas, it's one of the famous packages in Python, which allows me to interact with data and table, and a lot of applications, the pandas package does have. So and then there can be several other uh, methods in pandas, or there can be other famous packages. So what it does is the SWOT package actually allows me to use Python like syntax, which can be pretty much understood by cache server as well. So the role of SWOT package is to act like a translator between Python and then your cache server. So eventually what is happening is you might end up triggering, for example, this head function from your Python interface or Jupyter notebook, while the SWOT package would eventually translate it, and it will ensure that your cache server understand what is being asked for, and then it will actually do all the jobs and send back the results to it. So you need a SWOT package in between. So as I said, that whether it is SAS command or Python or R or Lua or Java or whatever it might be, SAS via or cache would understand this table.fetch cache section only, irrespective of what might be the actual native command given from the client. In between, somewhere, the SWOT package's responsibility is to ensure that this translation happens and then the system understands. So whether you're using SAS, Python, or R, it will be the same cache action that is used regardless of the interface and API. The results obviously will be equivalent as long as the seeds are equal, and then this information can be passed across irrespective of the language that we are using. So that is one thing one must understand when we are talking about open source integration. You need a SWOT package in between so that cache can understand what is being asked or what is being desired in a typical thing. Again, there are several other Python packages that are there to support a variety of activities. So these packages must be, let us say, if you're using Python, you have to import them first. Similarly, if it is R, then you have to add them as library, and there is a great list of such packages that are available to interact with SAS via using, let us say, Python or R. So let me give you a glimpse of these things. So we have SWOT packages that is there. Then we have SAS Py, that is SAS Python package. There is a lot of capabilities, a lot of functions are supported for streaming data. ESP is event stream processing, and then event stream processing, of course, using native commands of SAS Castle or CAS language. You can actually manage your streaming data. You can run models pretty much on the real-time basis, and a lot of applications in industry are there. Likewise, the package that is must be imported while interacting with streaming data is ESPPY. Similarly, for any deep learning, SAS would have its own sets of packages, CAS sections. However, if you want to interact all those deep learning related activities on CAS through Python, then the package that you need is DLPY, that is deep learning Python. And likewise, for optimization, we have SAS OPTPY, and these are all example. There are other communication packages between SAS and this one, that is SAS CTL. So these are all the packages, and then more and more new packages keeps on coming depending on what our client needs. And those packages are, once again, you can download it like any Python package that is there. Most of them are available on GitHub and other repositories, and all that information is available in the public domain. So going forward, in the webinar, I would also be sharing some of the learning resources. I'll exploring them and I'll share it with you. So do not worry right now. But the idea is that you got interaction with SAS via through Python or R. Be ready that you would need packages. Those would more like depending on the field of study, like for deep learning, you need DLPY and all. Then you can leverage your syntax of Python and then power of SAS. Both can come together. And once again, please understand Python is just as an example that I'm taking. The things are equally applicable whether it is R language or let us say any other language for that matter, Lua or Java. So these are some of the beginning points to start with. We will explore a bit more. I'll give you more things, and then we will also move towards the demo. But what I would do and prefer is, for example, it was almost 1 hour that we have been there. Let me check the chat in case you have any queries and questions. So I would call it, let me just check my chat. Before we get further into it, please feel free to have any quick queries. You just want to put them in the chat. Let's address them first. Then we'll move to the next part of the demo. Sorry, next part of the webinar. So meanwhile, I'll just explore the chat in case if there are any questions, I would address them. If there are not any, I'll proceed. But I usually wait for a couple of minutes in case you have any questions. You please feel free to type them in the chat. Well, guys, welcome back. I think let's move on. I couldn't find any of the things in the chat. So I think let's move forward. Well, so let's move on. See, now let me talk about and just, showcase some of the things on the slide and then create a case for the demonstration that I'll be taking in the webinar. But then before we go to the demo, let's see a few things. And let me set up for that. So first of all, I could actually end up writing codes on SAS Studio. For example, I could write my Python program within SAS Studio. Now that's the interface where you want to use proc Python, and then you want to run the code. So that's one of the ways in which you can interact via SAS Studio, still using the language of Python. Of course, there's a bit of a syntax around proc Python, but it would obviously be supporting all sorts of Python syntax that is there, and this can be triggered through SAS Studio. Here is another example of Python code getting triggered from the coding interface of SAS Studio. So that's pretty much there. You could also incorporate your Python code within the SAS Studio flows. Now remember that SAS Studio is a programming interface supported by SAS. Within that, it actually allows you to create a logical connectivity within set of codes, and you can create these flows. And now your Python requirement or interaction or usage of Python code could be a modeling activity, could be a data manipulation piece which you want to leverage through Python. So Python could be well integrated within the SAS Studio flows. Now, it is a bit of a thing that, what is SAS Studio, what is SAS Studio Flow. Nevertheless, these are all interfaces in which, you use SAS programming language to interact with SAS tables or CAS tables for that matter. So SAS Studio is a programming interface, but within that, there are a lot of facilities. So what I'm showcasing here in form of screenshots is simply, how you could actually end up writing here. For example, I just showcased this uh, Python program writing in SAS Studio. Likewise, you could also use your Python code in your SAS Studio flows as one of the nodes or one of the parts. We have SAS Model Studio. Maybe some of you are already using Model Studio. It is a pipeline-based machine learning tool that allows you to create. And they're also, the set of nodes, these are all available as open source code node. And then, that node could be integrated as a part of your overall analysis. and then you can write the code. For example, that will be drop down with which kind of language that you want to pick up. So there are options over there, and Python is just an example I'm giving over there. You can open the code editor, and then you can plug in your Python code over there. Of course, there is some logical connect that has to happen with the elements of the pipeline that is running in the Model Studio. So SAS would give you a list of variables that you could actually leverage within your Python code. For example, if you're running a model, here in the code, you need not actually worry by typing manually all your class inputs, or target variable names, or what is going in and out, or references to the models. These columns and variables are automatically created by SAS, and all you need to do is to simply just plug them in your Python code and use them. So it kind of speeds up everything. So all your requirements handled beautifully, both by the power of SAS as well as power of open source. So whether it is SAS Studio, whether it is Model Studio, there are inbuilt mechanisms available to support your open source requirements. Well, these are just some screenshots. I just wanted to illustrate the fact here. However, when we go to the demo, we will be actually, doing everything through a Jupyter notebook, so that, it gives you look and feel, and develop an understanding around how the Python interaction happens. So any IDE, for example, here is an example of a Jupyter notebook where you are importing, for example, the pandas package, and then, making connection to a cache server. And see, we will see a bit of a detail as we go to the demonstration. But for now, just the screenshots I wanted to showcase. Well, so few things that we need to understand, that when we are using, let us say, in a typical environment, for example, I want to use a Jupyter notebook, whether it is R or Python. I want to trigger cache actions through Python or R, and then SWOT package has to be there, and then other packages also need to be imported. For example, if you're using deep learning capabilities on cache, DLPY is the package that you need. So likewise, it's just an example that you have to load all the necessary packages, whether it is R, wherein we use this library function. If it is Python, obviously we use import command. So these are some of the things that we have to take care. And once taken care, then so remember that packages will differ. So these are native packages we are talking about, and the SWOT or DLPY or SASPY or SAS opt py. These are all the examples for bringing in the relevant package that would be helping you in your analysis. Then you need to connect to the server. So there is just an example of how you might want to connect. So there has to be an object name, and then you have to pass in through the cache, and whether it is R or Python, typical syntax would remain the same. You will pass on the host port, username, password, and the protocol that is there, so that the connection to the server can be established. Then you want to read the data to the cache server. Now you see that typically read.csv or read_csv. These are like packages, similar syntax, everything, and you want to load a CSV file to cache server. That's pretty much possible. So these are some examples of the tips and bits, and the syntax. And anybody who is familiar with, let us say, Python would appreciate the read_csv function, or similar functions could also be deployed. So now let's move on. You could use your familiar functions in R, like dim names, head summary. For example, in Python, it is list, head, or describe. So once you have uploaded the data to the server, the moment you have the reference to it, you would have the SWOT functions, which are more or less similar to any native languages function. They can be easily used for handling or getting more information about the data. Now, only thing is, the moment you start using Python or R, let us say, with the cache server. So some of the results, for example, they are automatically returned back to the client. Some of them remain on the server. So again, it depends on the design of the SWOT package, and that's where you might want to spend some time. However, what we want to talk about is that we distinguish between certain kinds of data. So we have something called as cache data frame. So, and we can actually detect, even if we do not know whether a given output table is a cache data frame or something else, we can actually test that out. However, first of all, let us understand that there are some results which will be automatically returned to the client. A cache data frame is just a copy of the in-memory data. It's not usually that big as compared to the original data that you might want to analyze using cache server. It's more of a summarized table. And those results are free to be analyzed, whether you want to analyze it on the client or you want to simply keep on analyzing it on the cache server. That's pretty much possible. So class and type, for example, if it is Python, we end up using type. If it is R, we would use the class command. And you can have output like cache table. So as long as the answer for your type command is cache table, that data is lying on the server. Whereas the moment if the answer is, for example, in case of R, cache data frame, or in case of Python, if it is SAS data frame, it's the table that is available both on the server and the client. And then, for the SAS data frame, you could take a call what to do with that, whether you want to keep on analyzing it on the cache itself, or whether, more advantageous is to use it on the Python. So see, the point here that I want to make, and in fact, you could actually convert a cache table and you bring it over to your client as well, as long as it is justified. So the point here is one must be using this integration facility depending on the maximum advantage principle. So if cache is deployed, so that you can leverage the benefits of faster processing, heavy loads, etc., then it must be used over there. And then, if certain things you have already pre-processed and the data is not that big and Python codes already exist and you want to leverage all of that code, then, the data can be brought to the client. And one must know what type of data we're talking about. Even in fact, a cache table could also be brought into the client. There are functions available. However, if you're the type of the data, for example, in Python is SAS data frame, it's available at both the places. It's now my judicious use how I put the usage to the maximum advantage. You can always refer to the table. For example, if you want to create references to the table, for example, there's a linear model, and then you want to say def cache table, and then you want to pass it on as the results, and then you can apply the head function onto the table lying in memory, or let us say head function in Python. So the cache table must be referred by an object name in case you want to use SWOT functionality. Now, if you want to bring data locally, those are also possible. So in Python, we call it to_frame function, whereas in R, we would call it, to dot. So again, these are all the syntax that is supported by SWOT. And the point I want to make is that you're free to choose whether, a typical cache table should remain on cache and you continue to work over there, or else, if it is not a data frame that is available both on server and client, if it is exclusive to cache, you just want to bring it to the local client, still that is possible. So there are functions and support available to do all of it. Now, what should be the best practice? As I keep on saying throughout the webinar, that what we shall be actually doing is to follow the best practice. So let cache do the heavy lifting. So you want to take the advantage of speed and efficiency of the distributed environment. Things like you want to manage the data, you want to explore variable or maybe create new variables, and then you want to create models on the server. All of it can be done on cache. And that's why you probably have cache at the first place, because the data size in your organization and processing requirements are getting huge day by day, and the traditional systems cannot handle that. So you are going for the cache. So do all the heavy lifting on the cache. Whereas, for example, there are codes and activities which are lying with you. You want to leverage that, which could be simply, I'm just taking a very small example from the modeling world, wherein all the computations or the data manipulation or running and execution of the model would happen on cache. Wherever when the results come, you just take those summarized tables back to the Python, and there you might have codes or reports that are all well written in Python, and you just plug the data in, and all your work is ready. So a simple example could be that all the modeling work and calculations would happen on cache. The moment the results, for example, you want to create ROC chart, you find it that, okay, I do have a lot of code of in Python creating ROC charts. I can actually plug that in onto the client. So in that case, you're going to bring the processed data or summarized output. Let us say, ROC data, or maybe lift values, or it could be any other, like you have confusion matrices that are there, but you have a nice code in Python that showcases it in a particular manner. So you want to leverage that. So heavy lifting happens on the cache, whereas any other activity you have advantage, you are in advantageous position, you have benefit of having the code already existing. You do it over the client using the native open source functionality. So you could compare models and create graphics using these things. So that's the best practice. Now, I just want to set in a context before we get into the demonstration here. While in the demo, we would be talking about modeling. So needless to say that, the different types of models that do exist out over there, and we will demonstrate them using different types of cache actions. Likewise, there could be explanatory modeling, like models like regression, where you get the equation, you have confidence intervals, p-values, etc. Usually explanatory model is used with small samples, small data, and this has been the traditional way of looking at inferential modeling or explanatory modeling using statistics. Nevertheless, you have other type which is getting more popular, which is predictive modeling, where all these things with big data are deployed. For example, you want to predict fraud. So there you might not want to immediately look into the explanation or the explanation part. Your idea is to, as long as you can use any model, be it a black box model like neural network or support vector machine, you just pick up that thing and you just want to have your predictions right or more accurate. So let us say the job of fraud officer might be to first detect fraud more accurately. Then later part becomes, how you explain the fraud or you went into that. And there could be different methods of doing it. But as long as my focus is on prediction, I would end up calling it as predictive modeling or supervised learning, as I want to call it. Wherein, the features would be, there are very, very large sample sizes. We've got many predictor variables, for example, and accuracy is what you're looking for, not the explanation. And of course, you're going to validate the model and other things to ensure that whatever model that we're using is logical enough. Now, having said so, we got a model which is too simple, or a model which might be too complex. See, neither of these things will work. So what we do is take the slice out of the training data, or it could be a separate data which is similar to the characteristics of the population, and we run a series of models to find out what is the best fit model. So this is basically what the model validation do. It helps you to avoid underfitting by avoiding too simple models, and it also avoids overfitting by avoiding too complex a model. So you run those series of models onto your validation data, and then in between the, you will strike gold, which is the good model that fits in, and it adds to the generalizability of the model and applicability to the new test data that might be under use. So these are all the capabilities that might exist in your code for Python, which could be using cache actions or other Python packages, and everything happens then on the cache server. But this is very general concept, overfitting, underfitting, and then just figuring out what model is the good. So all those activities could also be done on cache. You have to divide the data. So we will see in the demonstration that the data has to be divided into training and validation. So you will build the model on the training data and you will evaluate on the validation data. So here I'm just telling the very basics of the modeling, because my demonstration would take you through these kind of things. So I just wanted to talk about, but in principle, these are well-known ideas behind any modeling activity that you might want to take up. So training and validation. And then, of course, the algorithms could involve anything. For example, your algorithms might be a logistic regression. So let me just go back where, you got some binary prediction and then there is an equation to it. I'll just briefly tell, about these models a bit. Of course, that's not a typical modeling training, I would say. But then logistic regression are purely equation-based tools used for either binary or multinomial classification. You could also deploy, decision trees, which are rule-based techniques that are there. Variations to regression like techniques might exist. For example, you could have generalized linear models or other kinds of models that are there, whereas decision tree models go by the rule-based logic and it finds out partitions in the data, and those partitions or rules tries to figure out how well your categories can be separated, as long as it's a classification problem we are addressing through a decision tree. So that might be useful quite a number of times, and sometimes they outperform regression. But needless to say, there is no general rule wherein I could always say that logistic regression is always better than decision tree or vice versa. Random forest is an improvement on ensembling of decision trees. Those are all the techniques wherein instead of making and applying decision tree algorithm one time, you actually end up applying on several samples that you take out of the training data, and you perturb the tree. You run several trees, similar trees, but different each time in terms of the sample that goes into them or the number of columns you want to consider to run each of the trees, and you have a large number of trees predicting, and then you go by the voting. So all that ensemble model philosophy goes into random forests. Similarly, the trees could also be created on a sequences basis, wherein the first tree is applied and then there are errors, and the second tree tries to minimize those errors, and every time you're doing it, you're actually boosting the gradient. So again, these are all different algorithms that are there. Neural networks, for example, the complex set of equations using layers and layers of nodes. In fact, it's a multi-layered, several equations all coming together to give you a predictive model. So you got all these algorithms, and in fact, these algorithms could be deployed through or via Jupyter Notebook, and then let them run on the CAS server, and probably we'll take the comparison results back and then make comparative report using Python. So I'm going to show you a demo wherein these things will come up. So I'm just creating a background for the demo by discussing some of these techniques that are there, and then finally few more things. The model performance characteristics that are there, which probably you are already aware if I'm not wrong. So typically all these models, you have to track them, you see how they are performing. So from time to time when you're deploying model, your results are coming up, you need to evaluate, and the evaluation can happen with respect to any aspects, be it training speed or the scoring speed or the noise tolerance, or let us say interpretability. So yeah, picking up a best model, once again, it is very, very specific to a requirement and a site, but there are general guidelines available. You should look at some statistical measures. That gives you an idea about the performance. Could be simply, the speed that you're looking at, or sometimes both speed and accuracy that are desirable. So depending on what situation you are in, your best model out of all the algorithms or the models that I talked about would vary. It all depends on the particular requirements at a given site. So few things like the statistical measures, for example, I'm sure we are all aware of what is the confusion matrix. So all the true positive, true negative, or false positive, negative, these calculations are usually done once the models are run. And then based on the confusion matrix, you want to see which model has most accuracy. Or for example, you might want to talk in terms of the numbers like sensitivity or specificity, which is nothing but some ratios created out of the confusion matrix. For example, your sensitivity is nothing but true positive divided by TP plus Fn, or else your specificity is nothing but your true negative proportion with respect to Fp plus Tn. Nevertheless, higher the sensitivity and the specificity, I mean, the highest values could be one, that is obviously the idealistic high value or mathematically possible high value. So closer to one are good. So likewise, ROC curves, for example, can also be created for comparison of the model. So they all represents the probability distribution, etc. Sensitivity by one minus specificity. Sometimes it's called true positive fraction. This is false positive fraction. Higher the curvature in the ROC curve, those models are considered to be good or better. So likewise, I could have the C statistics, which is area under the curve, and likewise I could use these thumb rules. For example, if the ROC index is less than 0.6, we have a weak model. Else, if you want a stronger model, we have this ROC index of more than 0.7, which we call strong model. So these are all the items that are there. And similarly, you want to have the lift chart. So, so lift, for example, a 4 would simply mean that, if you're using a model for a given top probabilities of, let us say 5% to 10%, a value say 4 simply means that, how better off you are while you are using this model for predicting the probability vis-a-vis just a random model. So higher the lift, for a given model, the better might be the model. So these are all the things that could be used for model comparison purposes. So I'm just introducing them because in the demonstration I might want to use or demonstrate some of these ideas by taking an example of modeling activity using open source integration. So what we'll do is we'll go to the demo, and before we go to the demo, let me once again check with you whether we have any queries and questions. So once again, I would stop temporarily here and I'll just check the chat. Meanwhile, you want to put in some queries and questions onto the chat. If you haven't, please feel free to do so. If there are certain questions in the chat, I will address them first, and then we'll move on to the demonstration part. I'll just wait for a couple of minutes in case you want to ask or write any questions. Please feel free to do so. In the meantime, I'm just checking my chat for any queries and questions. Well, great. So quickly, I think I got one of the queries and the questions that was there in the Q&A part of the chat. Well, so the question was, can I integrate or how do I integrate with any website that might be there? So see, the possibilities are both ways. For example, you might want to read some data from the website, or maybe it's a ticker data, so it's a streaming data, or otherwise it's just data that is there on a web page and you want to bring it to the SAS. So there are possibilities. For example, through SAS data step also, the data could be read. Of course, you need to have the appropriate rights to read through that data. We got again API packages that are available. There are specific names and steps to do it. For example, in event stream processing ESP, you could read the data that is streaming out through a web source, and we have got packages for that. So of course there are again specific details. If you need the documentation of ESP, will give you out. Similarly, the other hand, you want to put out the data onto a website, showcase some results over there. Again, there are multiple ways to do it in this. As one of the examples could be that you have, let us say, a certain graphical output that is coming out of the SAS visual analytics. Now the SAS will generate a URL for that. For example, you might have a nice chart and that refreshes itself, etc., and that is happening in your via visual analytics environment. And then it creates a link for that particular thing, and that link can be embedded in any of the other pages of your SAS solutions, or else you could embed them as a typical link embedding process that you would do with any other link. So all those possibilities are there, but once again the answer is yes. We got SAS communities over there in case you want to know more or details over there. We have documentation for exact steps in case you're looking for that. That is also possible. But right now, yes, the answer is yes over there. Now, well, guys, let me just move on to the demo. I don't think that there are few further questions I could see over here in my this thing, but let me just check. And also, let me start with the demo of, I will use a Python machine learning demo to showcase how, you can interact with CAS and still be through Python. So these are some of the things I'll be showcasing. But before, let me go ahead if there is any more question and answers. There are some other questions coming in the chat. Let me first address that. There's a question, has there been any issues with deploying a not good fit model? So let me try to understand the question. Probably the question is, I'll repeat the question. Has there been any issues with deploying a not good fit model? See, if the model doesn't have a goodness of fit, there would always be issues. So let me give you an example. A bank, for example, and typically, now the regulators also have these regulations that why you should assess the goodness of it before you deploy. It might have serious consequences. Just to give you an example of what happens when a model is deployed which is not having a good fit and what goes wrong in the process. There could be monetary consequences, there could be regulatory consequences as well, especially if you are in a heavily regulated industry like banking or insurance. Now, let me give you an idea that, for example, you have a model which is not that good, and it is used to predict a very crucial item. For example, it is used to predict probability of default in case of a credit default scenario. Or let us say you think of a situation where you're using a model to predict premiums. And if the model is not good, it might predict, under predict or over predict. Let us say things like premium for insurance company, default rates in a case of a credit card bank, or probability of a fraud in financial transactions, be it taxation, government or non-government, or any other kind of things. In any of these cases, if the prediction goes wrong, either you over predicted, let us say the premiums are projected or predicted to be higher than that is required, you deploy that model and use that premium in the market, you're losing out to the competitors. Similarly, if the probability of default, you're under predicting and you're not able to correctly predict the probability of default, you end up giving out the loans, and your NPAs or your loss given default or will increase. So there are monetary consequences there, and in case if it happens on a large scale, then the regulator might be putting penalties. In fact, your models in regulated industries has to be validated and has to be audited as well, and you have to manage your model risk management separately. If you look at the literature of risk management, there are guidelines like the TRIM guidelines, targeted review of interim models in Europe. Similarly, there are guidelines available in United States, and likewise global guidelines are also there. You need to be very, very careful in talking about the goodness of it, evaluate it, and one must audit that as well, especially when it comes to banking and insurance and other things. So there are consequences of these things going wrong. Well, coming back to a few items that are there, let's check this out. Okay, there are another question popping in. The question goes like this: what if we have a model that has been already deployed, and what if you find out issues post deployment? See, remember that you're right. This will happen if the model with a good fit has already been deployed. What is the resolution? Okay, if the model already has a good fit and it is already deployed, see, it has to be monitored. First of all, you do a review. So let us say there is a churn model, which is a good model. It predicts, and every week or every quarter, so every week or every 15 days or a month or a quarter, depending on which industry you are, you have to monitor the results, and you have to see to it that your predictions are as per the requirement, whether the model is under predicting or not. So there are model performance reports, there are deviation indexes, there are stability indexes that are there. The moment these deviations starts to occur, you have to actually retrain your model. Sometimes you have to retire, create a new model from the scratch in the light of the new data, or sometimes you have to simply retrain the model parameters. So there are a host of activities that needs to be done once you have seen those models. So likewise, there are corrective actions needs to be taken. So hope that answers the question. I'm not sure whether I understood your question correctly. While in the meantime, let me share my screen and go ahead further. I'll be looking into any queries or questions furthermore. Okay, great. So let me share my screen. What's happening here? I'm not able to. Okay, yeah, it's already there. So let's move on to some of the things now. So what I've done is, see, I'll just go full screen for a while. See, now coming to the demo. What you see here is that, I'm connected to a virtual machine. I've already done some of the steps over there. For example, here in my installation, I have Anaconda 3 installed, and through Anaconda, I have already started my Jupyter notebook. By virtue of that, I'm already here on my Jupyter notebook with this particular item, and I'll just increase the font size in case it helps. Just zooming in a bit. See, what I'm going to do is to showcase some of the basic integration principles, some sample code with a case study. We're going to interact with Jupyter notebook, and then some CAS actions, and then Python like code to build up a model. So I'll just give you an overview of the predictive model. It's a fairly simple demo and example. So here, let's say, there's a bank or a financial services company which actually offers a home equity line of credit to its customer. And of course, we have the past data. There are several of those data points available, and 20% of the clients have been found to be defaulted in the past. And we have all the data with respect to the geography, demography, and financial variables. And now we want to just build a predictive model. And that is what I want to do. And partly I would use Python, and partly I would use CAS actions throughout the code. Just to give you a little bit of a context, of course, you might not need all the details at this stage. We have a predict variable or an outcome variable called a target variable, which is binary, 1 and 0. 1 is when the applicant defaulted the loan, and 0 is when it's not. So 1 is the event of the modeling or the focus area of the modeling, 1 being defaulter or a bad customer. 0 is the regular good customer, pays all the things on time. And then some of the demographic variables are there. For example, you have, the demographic goes a bit down. For example, years at job, value, and then profession, etc. The value of their properties. I don't think the age and income are, let me figure out whether they're important, but then, the job and categories would actually give a hint about that a bit on it. And then, what are the reasons they have got the loan, what's their debt to income ratio, how many credit lines they have, what is the amount of loan request. So it's less of demography, I would say, but more of, the loan related parameters, like the age of the oldest credit line in months, how many total number of credit lines they have. These are the column names, debt to income ratio, number of derogatory reports, occupational categories, loan, mortgages, credit inquiries, etc. Now, let us begin our journey. Now, I want to use Jupyter Notebook to do everything. I'm not going to open any of the SAS tool or SAS softwares, but I just want to take the advantage of CAS server. So here, for example, the first item, if you recall, had it been R, would have used library syntax, but this is the Python syntax I just want to showcase. So what happens here is the first thing that I have to do is to simply, uh, you load the packages. So I'm importing the SWOT package, scripting wrapper for analytics transfer, then pandas. So a bit detail here might be helpful. So this is the Python syntax of importing. And then, the SWOT package is a Python package that enables you to interface with SAS Cloud Analytics Services or CAS. The in-memory server I have been talking in the earlier part of the webinar, and it is the centerpiece of the SAS wire, does everything over there. And using the SWOT package, you can write a Python program that connects to a CAS server. You can analyze large in-memory data sets and then work with the results of the data using any of the data wrangling techniques in Python. In fact, what we're going to do is all the heavy lifting, all the model building will happen on CAS server, whereas the comparisons of the result or creating things like ROC chart, etc., will happen on Python. That way, we'll be able to see both the activities happening on CAS as well as Python. Pandas package, I believe we are all aware Pandas is a Python package that provides data structures that are designed to work with relational or label data, such as data frames. And it is a commonly used building block for data analysis in Python. Then you have matplotlib here. If you see, we are importing pyplot as PLT. So see, matplotlib again is a 2D plotting library that produces publication quality figures. Again, of course, used with the Python platform, and pyplot can be used to create things like histograms, scatter plots, and others. And this command matplotlib inline, it's basically it instructs Jupyter to print plots produced by matplotlib within the notebook rather than to external file or output destination. And you see the last line, the SWOT options CAS print message. This is a SWOT function that can be used to turn on and off messages printing of CAS actions and result. We would actually need it. We have set it to true so that we know what's happening. Now here, for example, the first cell I'm going to run, I'm just going to, I could have run the entire code at one shot and everything, but let's go cell by cell. So I'm going to run the first cell. That will actually import all the packages that are there. The next part is that I have to start connection with the CAS server. So remember that in the slides I was talking about that you have to connect with the CAS. So you get the server, the port, the login ID, and the password, etc. Again, at your side, you would have your own login IDs, the server numbers, etc. But then, here, the host name and the port are very, very specific to the installation I got. Now, I list my sessions. So let me just refresh it because I've just run a fresh. So I'm connected with the user ID student to the Python session. Again, these timings, etc. This is the recent connection that I've just created. This is some earlier, I did that today in the morning. I was just testing the system, but now here, this is the latest one. Remember, the time is all based on, I believe, US timings or something. I also want my session to be there. So this timeout thing that you see is basically ensuring that you are connected to some good number of times. I just want to connect. For example, this webinar would go maybe another couple of hours or so. So I would give time in seconds for let's say at least 3 hours. So even after the webinar also, I might want to use it for a while. So I'm just, connecting for a while for next 3 hours to the, so I don't want to timeout this. If timeout happens, I can again reconnect. But this is just to show you the capabilities that while you're connecting to CAS, here we are using Jupyter Notebook Python-like syntax. Same logic applies with R or any SAS session or any other programming language. These are the usual steps. You begin, you import your packages, you make connections with CAS, you set up how much time you want, when you want the timeout to happen. In fact, you can have as much as the time you want. It's not necessarily that it has to be done for certain number of hours or something. You can make it, that you want it forever kind of thing. Theoretically, that is also possible, provided it is required. So you see, the system sends out messages that your actions are active, you have been authenticated, your time out is this, you are US, you are in the state of connected, etc. Now you see that I want to load some data. So there's a data lying already somewhere on the D drive of my system that is there. It's a CSV file. It's the same file that has that BAT target and all the other items that are there. So this is read underscore CSV is just like a CSV capability in Python that you can read a similar thing. Remember that con.read underscore CSV will be processed by the SWOT package. And then there will be a cache section. So automatically the system does everything, read the CSV file, put it onto the cache. And then, we are creating a reference for HMEQ data. The file name is HMEQ. I want to keep that original file name as it is. While I want to use references in my cache sections, I'm passing the table name to an object called in data. So just creating a variable for addressing it in my code. So in data would be the name. Remember that it could have been any name if I wish to. Similarly, this object could have been of any other name if I wish to. Just to give you an idea that you can load any kind of data. Example here is CSV data being loaded to cache through a Jupyter notebook. So I'm going to run that, and then it says the table has been created, uploaded, and let us see how the data is distributed. So this is now my cache section table. I'm going to look for table details at node level, cache user, and this is the name of the table that is there. So I could see at the node level. Also, I could see at the block level. So when you have distributed data, you got something at the node level, something at the block level. So I'm going to run this. I'm also going to see later on at the block level. Now at the node level, you could see that there are 16 blocks available for the data. Now I want to now go at each block level. So I'm going to run this keyword with block. So for each block, you could see that it tells me that this is first block with active. This is the node that has been defined. This is how the data size and the rows are. Remember that what we said, it's a distributed data kind of a thing. And all this distributed data is spread across 16 different nodes in the grid. These are all the details that are there. Of course, these details might be useful for somebody who is looking at the grid, but we have the capability over there. Now I'm using some Python capabilities. I'm going to bring this node data. Since it is this node data table is available both at the client and both at the server level. So I'm going to refer it to the client level. I'm going to display the node data. I'm going to use the PLT Python feature of creating a plot of distributed data and with number of observations. Now this is all the Python syntax. The moment you see display, PLT figures, etc. This node data is just a call to the table with the table details and number of rows. And then once it is there, I will see to it. This automatically filters for the table details and rows, and then displays it, and then it creates a plot. Now let's see how the results looks like. I'm not very specific around the Python syntax for creating a plot. I'm going to just run it. This is the display, and this output is coming because of this cache section, table details, rows, and other things, and I'm displaying it. I'm also displaying some of the node data. Remember, display the Python function. 5960 rows, each of those 16 rows have this much. And this is how the plot that has been created by the native Python client that we have. So once again, the axis is from 360 onwards to something. So on an average, we have 300 plus rows at every node, barring one of the nodes that is there. Again, this distribution is best optimized based on the memory and the resources available for each node. That's why the number of rows might vary. Well, so having said so, we have distributed it. Now what we're going to do is just showcase some of the capabilities of SWOT package in a Python-like syntax manner. So let me get the table info. Here is the table info. This is the time when it was created, modified, etc. So I'm using this table. action with table info, sorry, table action set with action table info. I want to check out what type of table is this. If you recall, this is cache table, which is this table is in memory. Had it been SAS data frame, it would have meant that the table is both available on this server and the client. Nevertheless, you can refer it and bring it to the client as well if you wish to. This is, now the moment you say cache table dot head, I could straight away use type, because this, the moment you use dot head function, it will create a local copy, and I can simply use the type to check that. It's the SAS data frame now. So that's how, the logic when I was trying to explain on the slides, that how, that some tables are automatically available at both the places. I want to call, see the list of all the SWOT functions. So see, this is, I'm just looking at first 5 functions. You can always see, and if you want more help, you would always write this help function for SWOT. So I'm just going to demo some functions here. So we have the SWOT package functions like cast, cast table, etc. There are more of them. In fact, a long list of tables that is there. If you need help, you can always write help SWOT.cast to get a help of it. Again, online documents are all available if you simply want to read. Even a simple Google search on any cast syntax or SWOT packages, they're freely available on the internet as well. This is how the help file would look like. It tends to explain the SWOT cast function, how you do it. In fact, it can explain several other functions. So this is a help documentation that is available. Nevertheless, as I said, you can also fetch it, not here, but you can fetch it anywhere you like. So these are, first of all, the basic things that we have just done. We are on a Jupyter notebook. We have loaded the packages to the Python. We have made connections. We have known our data details. We have spread the data over the grid. We have created a chart. And then we have also, looked into some basic items over there. And we could also now explore the data, like what's the shape of the table, what's the mean of this thing. So let me do first some basic items here, and then I'll see if there are any questions in the chat. So you see, this is how the display function and the list function will work. You would have the number of rows and the columns and the list of the number of columns that is there. Again, I could use mean function to see the mean of each of these columns. Specifically for bad, I want to put it separately because that is the count. So you would see it was around 20% of them have defaulted. Now this is the data that we are using. So the bad count or the percentage is around 99.9%. So as said in the beginning, it's around 20%. I can use the describe function, and I can describe numeric and character variables. Now, the moment you say describe, you see, basically it is giving me the summary statistics of the entire table wherever applicable. So you have unique value count, top value, frequency, mean, standard deviation, 25th percentile, 50th, 75th, or max. Well, so this is usually, the beginning steps. You want to bring in the data, you want to explore the data. Here are, the commands that are there, Python-like commands we are executing from the SWOT package of the Jupyter notebook. You can always compare, like this is the SWOT package display function along with the head function used over here. This is the original. So if I were to run this, I kind of get a comparison of, how the output looks like here and how the output looks like when I actually issue an original CAS action. So let's have a look into it. So let me first run this. So you see, the first table that you see is the SWOT package display and head function. So some 4 to 5 rows are displayed. The fetch also looks similar. Now the whole idea here that I wanted to show you is I've used some fetch is equal to 6, and the head function will bring in first 5 rows. That's the default behavior in Python function head as well. Here I have said give me 6 rows. Now if you see, more or less, they look similar. Obviously it is actually fetching the same table and all that. My point of showcasing here is this, that eventually both of them is doing the same thing. But this one is SWOT package, Python syntax based command. This is the original or actual SAS syntax based command or CAS action for table fetch. So action here is table. Sorry, action here is fetch and the action set is table. But more or less they're doing the same thing. And in fact, this will actually be eventually converted into this only before it actually hits the CAS server, thanks to the SWOT package. And remember that all these documentation, if you need, we are freely available. All I have to do is to simply go to the documentation.sas.com and you want to search for such action items, table of actions. They're all freely available. You can explore whenever you are free on your own as well. In fact, you can Google simply it around. Well, so this just briefly what I've done is started to simply explore the ideas behind the table. I'll continue to do more, but as I said, let me just look at the chat in case there is any question. Let me address that first. Well, guys, so let's move on and just let me know if I'm audible. In case I'm not audible, you please let me know. I just wanted to check my voice levels and sounds and everything. Is it all right? Yeah, thanks for that, guys. Thank you. Now let's move on. Now, well, guys, let's check this out. So let's move on and any question and answers, please feel free to ask. So looks like we are all good here. No Q&A. Okay, so yeah, let's move on. Well, so I was just showcasing how the stuff looks like. I want to just check on to the shape of the table. Shape will simply tell me, for example, how many rows are there. Shape 0, for example, in Python typically means that. Record count is actual SAS-based syntax for the CAS section. So I'm doing that. Results are the same, only thing the way it gets displayed is different. Here is the link if you want to know more about all the action sets that are there. In fact, you can Google it around in case you are interested. Simply type CAS action sets in Google and automatically the first few links will take you to the documentation of SAS and you can do that. Towards the end, I will show you like how to fetch the documentation, so not a big deal. Now, let me show you a few of, the CAS actions that is there, because the moment we understand CAS action, we have SAS PY, the SWOT packages simply, calling these action sets only. For example, here I have this action set simple. So again, I'm also calling for the help of the action set simple. So what it does is it actually allows me to create multidimensional summaries, number of rows and hints and so forth. It also helps me to perform Pearson correlation, linear regression. I can calculate frequencies, do a group by calculation, and then comparisons, etc. So there are many things out there. Now, what I'm going to show you is that let's say I want to figure out correlation between the loan, the value, and the mortgage. Usually these things are correlated. So let's run this, and you see the correlation action under the action set simple has calculated not only the correlation, but first it actually shows me the summary statistics. And then I have this correlation table with me. So I could see that the mortgage due and the value for loan has, the highest correlation of 0.7. And also I could do things like, correlation analysis if I wish to. That's the action set simple, and the action was correlation. Similarly, You want to calculate distinct values. So these are typical items that you might want to do with your data. For example, reason has 3 distinct values. There are 7 types of jobs. Bad has only 2 categories, and so forth. So I can get more insights along with data. It's a simple activity. I could do the frequency count also. How many bad, how many types of each job are there? What are the reasons for the loan? How many types are there? So I can actually trigger that. So you see the jobs are of, some 7 types: manager, officer, the professional, executive, sales, or self-employed. And these are the counts, for example. There are some missing values also, but I think, yeah, there are. And then bad doesn't have any missing value. You have then, reasons for loan, whether it is for the home improvement or whether it is, simply debt consolidation. So these are some insights I can get by action sets. Would also create cross tabs as well. Bad versus job. Which job category has more bad people, kind of a thing. This is called a pivot table in Excel, or you could use your simple traditional SAS to figure it out by creating a cross tab. Or here how using the CAS syntax you end up creating a cross tab. So I'm gonna run this. You got a cross tab like this. For different columns and different counts for the 0 and 1. You could also calculate cardinality, for example. I'll just show you the results of cardinality. You go to display the cardinality table. So this is what, how many of bad types, loan types, mortgage, reason types, etc., with all the other details. Alternative way of looking at it if you don't want to use the previous package. And then the record count, etc., that are there. See, so likewise, you could do that, and you can actually have the cash table attributed as card, and then you could use to display the head and the regular cash functions that are there, sort function, sorry, like the head function or the shape function. So you have to just give a reference to that in-memory table card. I'm just giving card over here, and I can just display the head of the table cardinality. Sorry, let me just go above a bit. So I can do that. Well, so these are nothing but the capability. See, if the focus were to modeling, you might not do all of it. You could have directly gone to, for example, you want to take a random sample. So I'm calling in the load action set sampling. And I can deploy, see, several sampling techniques are possible. In the action set of sampling, I could use simple random sampling, stratified sampling. I could do k-fold validation or partitioning, or I could oversample. Here I'm doing, simple random sampling. These are the commands, and all these things are there. As I said, if you just want to learn more syntax around these action sets, these are all freely available on our help documentation and pages that are there. You might want to check that. So I'm just going to run it. I want to create a random sample. The sample is created for me. I'm making it as a reference to my SAM. And remember that con.cast table. So this my SAM becomes a reference. My SAM 2_frame, I'm just shifting the data from cast to the client. So that, I want to create, let us say, histogram using the Python functionality. I want to show the plot. So all that I have to do is to simply bring the table to my local system. And this is where, that all the calculations can be done onto the cache server. And then finally, anything that, let us say, you want to display or something, maybe you have the code with Python, the capability, or else you have some reports that are created in Python, so you want to leverage that. So this is how you can bring a cache table which you have connected to a reference as MySam, and then two underscore frame is the function that brings in that, and then the rest is creating a histogram with 20 bins, and then giving the figure size. These are all Python syntax, and plt.show, that is show the plot. So if I were to run it, you see this is how the distribution for each of the variable would look like. Likewise, you have bad, which is at 0 and 1. We already knew the loan distribution, the mortgage due distribution. Some of them might be skewed a bit. So I'm doing some data exploration and diagnosis by creating this graph using the local function Python capability. Now here, once again, what I'm going to do is to create for the distinct count and number of missing counts on the data frame. I'm going to bring this table as a reference, and then I can use a SWOT function to display the table. And then I can bring the table to the local one, and from there I can calculate percentage missing and then create a plot basically. So here, let me just do it. So here is the table, this particular command, cache table distinct. Remember, these are capabilities of the SWOT or the Python. And you have the missing count available. Once if this thing is ready, all I have to do is to now use my Python functionality. And I'm going to just plot the percentage using the Python plot or PLT that I imported in the morning or at the beginning of the demo. So let's run it and see how the plot looks like. So you got the missing value plot, the percent missing plot. Now you see, if you got missing values, which we saw from the graph, let me just show you the graph. So these are the percentage of the missing values that are there. So some of the variables have around 10%, 12.5. Okay, let me just check the numbers exactly here. Yeah, these are percentage terms, 5,000. So yeah, the axis has to be red. 12.5% or 15%, and some of them as high as 20%. So it's a good idea to impute the missing value. This is typically you do in the data correction, that once you have the missing value, you want to impute them. Now here I'm using a cache action, impute, part of action set data preprocess. So this is the table I want to refer. I want to use the median method for continuous variable. For categorical variables, I want to use the mode method for the imputation, and that is the input from the cache table reference that I have created earlier. I want to copy all the variables to the new table that I'm going to create like this, and the output would be rewritten over to the in data table, and the previous table will be replaced. You see, the syntax is intuitive. Only thing, I just want to get used to it. After a while, you would see that typically the structures would look the same. So let us first impute the missing values. You see the impute info works in, and the imputation indicator has done, and then it is telling me what kind of imputation values for the continuous variables have been calculated, and then for the nominal variables, what kind of values have been computed. Now I want to see for any kind of machine learning problem, You need variable shortcuts going forward, in the sense that you want to have all the column info available, and then in the target column you want to just put your dependent variable. In your input variable you want to put your all the inputs. Maybe you want to create a separate array for nominals. So you see all this list thing and the function item. This is all Python like syntax, thanks to the SWOT package that I'm going to do, and create all my this one. And I'm going to just replace and keep only imputed variables. See the if statement that I've used in the iterator. K for k in inputs if imp underscore in k. So for the inputs, it will only take the imputed variables. That's what I want. Similarly for the nominals as well. And then, in the nominals, I'm going to add my target variable as well. So then I would have the display target and other things. So here I'm just end up creating variable shortcuts. This is all the table info I got. And from this table info, I'm going to pick up the imputed ones. See, we have in the table both the imputed and non-imputed values. So first of all, I'm going to create the target variable, inputs and nominals, and then I'm going to filter them for imputed values only. So if I have to run this block of code, you see this is what I get. I got the target as bad, and then these are all the imputed variables that I've got. And in the nominal variables, I've just created a separate item for nominals where you have the bad variables, you have the imputed job and the imputed reason. Well, so this is what I called data preparation. Now later on we will move on to the machine learning demo part 2, where we'll split the data into training, validation. We'll call in other algorithms. We'll apply the algorithms. We'll run the models. We'll validate them. Later on, we'll use the Python functionality to, of course, look into them and create some comparison charts, etc., using the local Python functionality rather than using the SWOT. So we'll run the models. We'll do the heavy lifting onto the space that we have got on cache, while we bring in results and create comparative reports on the local machine that is there. So remember that this is just the syntax available to you. I've just picked up some little examples here and there to showcase few things. Nevertheless, we are going to also check into the items that we have got, the training and validation that we're going to do. We're going to also do variable reduction and so many other items that we will do. I'll introduce more things that are there. So, but before we get into the modeling part, let me also, as always I do after a while, well guys, so let us have a look into some of the questions that we have got before we move ahead. So the first question, if I understand correctly, goes like this: how do you feed the data, ranging from seed as example or any other variable and data types in there, to be analyzed in your demo? So see, I fed the data this way, so I'll just show you what I did. So if you recall, well, this is business data from one of course, it has been morphed and all that. So this is banking data that we have got. Now, the way I fed the data in the demo was, if you recall, let me just show you the line of the code that is there. This was the data. I'm reading it from the CSV. Now, of course, if the question pertains to the point that can I synthetically generate the data, or can I do the random seeds and then create data based on certain distributions? Basically, that would mean synthetic data generation. So we got codes for that and products for that. Of course, there is a syntax for doing it that as well. It could be a simple synthetic data generation using known distributions. So SAS, you could actually create that. Of course, I don't have the right syntax to do it or showcase it here, but it can be done. The answer is yes. of course, you could generate any kind of synthetic data with certain random seed and any type of variable, as long as you know the distribution behind it. So whether it is a normal, Gaussian, log normal, or any other distribution you want to put. Usually, for example, the loan amounts might be, log normally distributed. There could be some other distribution, for example, usually if it is, we're talking about losses, etc. Once again, it could be a beta distribution, Webull or log normal, depending on the situation. Uh, Maybe you're looking at a certain age group of the certain segments of the customers, and then that distribution could be based on uniform. So statistical concepts would call in for certain types of variable to follow certain type of distribution. Like for bad, you could have a binary distribution. uh, so you need to know those distributions, and then we do have the syntax and everything available to actually uh, synthetically create the data or bring in any kind of data that is there. But for this demo, we are sticking to this because everything depends on uh, this table that has been tested out for all the models, etc. So that is number one. Let me check what is next. And is there another compartment in the software where you reference the data to be analyzed as either correlation, etc.? If I understood the question correctly, see, the data, if it were to be analyzed for correlation and everything, it is all done through CAS action. So we would say, or the question should be, what is the CAS action if I want to analyze correlations, and probably that I displayed as well. So let me take you to the place where I analyzed not only the correlations, you could actually pretty much do any kind of analysis you want. As long as you have the CAS action known to you, you could do that. So this was like finding out averages. So I'm using simply the mean function of the SWOT package, which is like the Python package. I'm describing the numeric and character data and summary statistics of it, like the unique count, frequency, mean, standard deviation, etc. And if you recall, for correlations, I use the package or the action set simple. And then what I did was I used the action correlation. So this is wherein I brought in the simple action set, and simple action set tells me that you can do correlation, regression, crosstab, or whatever you want. So we did that. And if you recall, this was the correlation. I just gave you a sample that for the 3 columns, we are looking for the correlation. This is the action correlation under the action set simple. And all we had is these items, the summary statistics, and then you have the correlation values. So, well, these are some of the things. Probably I hoped that this answers your questions. Now let's move on to the next part. What we were doing was we have created all the target and other variables. Now we want to split the data into training and validation. Recall that we discussed this, that you need to have part of the training data to be used is validation. And here we are going as per the logic to keep 70% of the data. I'm using seed value 919 just to in case if this code needs to run elsewhere, the seed remains the same. The partitioning indicator is true. So this will divide the data based on simple random sampling. So these are the outcast tables. So out of 5960, 4172 has been kept as a sample. In fact, I can view the partition. I'm just demonstrating that you have a SQL kind of a functionality to be available used as CAS action. So I'm bringing and loading that one. So here what happens is, after creating the sample, I'm actually, running this thing, and you can see the familiarity. You might have used SQL quite a number of times. So you want to, just call in the Fed SQL. So I've just added the action set fed SQL, and fed SQL is basically, you want to have the counts from the data for the partition indicator variable that was created above. You're bringing in count star from HMEQ and you're grouping it by partition indicator. You see how this connection has been working. Con is the server, my connection name to the server. Fed SQL is the action set, and the action is execute direct, and the query goes like select part indicator count star from HMEQ. Now this is how you could actually generate use SQL in the system, and likewise you could use the regular display function or the count function, typical Python or SWAT functions that are there, because counts will be a table that gets locally created. And then you have these are the count values. One for the training has 41722, and for validation we are keeping 1788. Now here, this is the Python interpretation of doing it by referencing to the table through a cache table name, and then I could use the Python functionality. Once I have the reference ready, I could use 70% is the partition. Now comes some of the machine learning algorithm, machine learning activities that are done. For example, here I'm bringing in the action set variable reduce, var reduce. So reduce the number of relevant columns for there. So there's something called as feature engineering. So this is just a small demonstration of doing variable reduction so that only relevant variables are called in. So the var reduce action set has been loaded. Here it is running. So you have table in data, target inputs, and nominals, all that are going. And I just want to ensure that I keep the variables that explain up to 90% of the total variance in the data. So likewise here, for example, it's easy to understand from the syntax that the table I'm interested in is the in data, that is the in-memory table that I've just created in the previous steps. Remember, it had all the imputed variables. The target is the target variable. Again, this was created previously. Inputs are all the inputs to be used in analysis, and the nominal are the nominal variables that are there. I'm going to run it. And if you want to see what variables have been selected, you could actually run the selection summary. Thanks to all the action sets that we have. So out of all those variables, you see, we are just going by the 15 and selected effects. Let us see how many are selected out of it. These 12 are selected out of all the 16 possible variables that were there. If I check the command, this is only for the selected effects, whereas the earlier one was the overall summary for all the variables that are there. So of course, I'm not getting into much of the details like what is this BIC, AICC criteria, or variance explained criteria, but the system will automatically ensure that the overall variance that is there adds up to 90%, and by that logic, these 12 variables are selected. And this is the list of all the selected variables that I have. Now comes, the part of how you apply all these techniques that are there. For example, I was just talking about previously in the first half of the session where that, you could deploy logistic regression, you could deploy neural networks and others. So here is just a quick glimpse of those techniques that we are going to use. For example, I'm going to bring in the action set regression. In fact, I'm also invoking .help, which is nothing but help for the action set regression. So, the system has already added the set regression, and then, it describes. So these are some of, the basic items. If you are from the machine learning background, you would appreciate that for regression, we have the GLM option. It fits linear regression models. For OLS, you have gen mode. For generalized regression models, you have logistics. Then, there's a variation to the logistic regression, logistic type 3. Then, it has scoring capabilities also. It can generate the code also that can be stored and then deployed in many other applications. Likewise, for gen mode scoring, for GLM scoring, we have, then there are calculations like lack of fit options, association options, and few others. The typical requirements of logistic regression this particular package meets. Now I'm going to apply the regression. You see how the table has been called in. The first, from the array of nominal variables, the first one was my target variable. That has been called as target. Then you have the model where you say dependent variable is target, effects are input, the distribution is binomial, and then you're also storing the model. Now, later on, once we store this LR model, we'll call it for scoring purposes, scoring the, let us say, the validation data. So all these options that are there are specifying different things. So very quickly, I'll summarize. The table specifies the in-memory input data source. Then you have the where clause, which is actually subsetting for the partition indicator one, which means the training data. The class variables are nothing but the variables you need to specify for all the classification variables, basically the nominals one. I'm using 1 colon because I don't want to include the variable that is there. Then you have the model where you have the target variable here, as I discussed, the target was stored specifically. Then you have the effects, and then the binomial, and the link is logit, and I would now run it. So this would run the regression. Now on the similar lines, I will be just bringing in different action sets. Like for support vector machine, we're going to bring in this SVM. Now, in fact, if you see, when you do regression, okay, let me just spend some time onto the results just quickly. See, we said that, okay, these are all the regression models that we are going to bring in. Here we have called in the regression. Now you see the output will have a typical regression like output. You would have the class info, you would have the convergence status, you would have the dimensions, you would have the fit statistics, for example, all that Akaike information criteria or maximum likelihood or AICC or SBC values that are there. You would have the global test of hypothesis, which is significant. Obviously, the p-value is far less. You would have the model info, the number of observations read and used, the output cast tables. And one of the key things, since regression is also used for explanatory modeling, wherein you want to see the impact of each variable onto the output. That's why you need this parameter estimate tables. And all these parameter estimate tables are nothing but giving you the estimate or the coefficient of each of the equation, sorry, each of the parameters used in the regression equation. So these are my list of coefficients that I have got. So you see the typical regression output is all available. Fitness of goodness of fit statistics, parameter equations, estimates, their independent p-values are also there, response profiles, and rest is the system also gives how much time did the system took for doing all that. So these are time in seconds. So fractions of seconds are used for fitting and storing and all that. Levelization. Again, these are performance metrics that might be useful for the administrators of the system or the grid. So they just want to see what is the overall utilization of each of these items that is there. Now comes another predictive modeling or machine learning technique, support vector machines. Now you see that the logic would still be the same. If I want to use support vector machines in the system, I'm going to click and check. First, bring in the load the action set SVM. Then you would train the SVM. Now again, for SVM, the support vector machine, this is a typical syntax that is there. So you need to specify the table first. So that's the same thing, and where clause is doing the same thing, referring to the training data from the dictionary name of the table index. Now the dict also is the same syntax that you might find it in Python, but it's usually here it is task action set syntax, more aligned with the languages like Python, etc. Then you have the target and the inputs and the nominals. Now again in SVM, you have to specify which kernel you want to use, and if it is polynomial, what is the degree, and then you want to save the model. So we're going to save the model, SVM model. Now all these models we are in the regression, we have used the store keyword. Here we are using the save state. All these models I need to save because I want to score the validation data, and then on the validation I'm going to pick up which model is the best. So that's the intention of saving all these models. Remember, support vector machine relatively is a newer technique, I would say, when compared to, let's say, regression analysis or other techniques. Regression goes back, I think, almost 110 years back, or maybe 105 or 106. 1906 it was used. uh, the concept was there beforehand, but SVM looks like it's not older than regression. So whether or not, let's not get into the history. I'm just going to run it. So the SVM runs, and likewise in SVM, you would like to see some numbers like accuracy, sensitivity, and specificity. See, SVM is also called a black box technique because you don't have an equation to interpret. All you would see, okay, got the fit statistics, it predicts the accuracy is around 84%. All you have is just the iterations, misclassification table or rate, we already know from the accuracy. The model info would tell, simply what kind of iterations the system did, what was the tolerance value. So it was all the simple internal settings that the SVM algorithm used, a number of observation used, and what kind of training results will come. So basically, how many vectors were there, number of support vectors, 1, 5, 2, 3. But these all these line items that you see over here, it is basically telling the mathematical structure. It doesn't have a direct explanatory business connection with the problem. So SVM is something like neural network, which is too complex to interpret or have any business meaning. But yeah, if it is giving a better prediction, why not use it? So that's the hallmark of techniques like SVM. So not much of the explanation here, but yes, this thing works. Now let's invoke the decision tree. Now onwards, you will see that I'm doing almost pretty much the same thing, only the name of the algorithm changes. Once again, I'm gonna load the action set decision tree. I'm gonna call the help. Now let us see what capabilities does this action decision tree has, or the decision tree action set. You see, I can actually end up training a decision tree. I can train it, score it, split it, prune it, merge it. I can also go for random forest by using these keyword like forest train. I also have GB train or gradient train and other things like that. So gradient boosting could also be done from the same package. Random forest could also be done from the same package. Now I'm going to run this decision tree. Typically the same syntax. You specify the table with the where clause. You specify the target. You specify the inputs. Specify your nominals and where the table should go. Cache out, that is DT underscore model. So that's pretty much creates and saves the model in the DT model. So I'm going to run that. Now for the decision tree, obviously you have some output coming in, that how many nodes were tried. These are all the settings that are there. You have the output coming in. And let's see what else we have. If we have something, usually, you can have more output of the decision tree wherein you want to actually check out all the rules if you wish to, but right now here we are not bringing in that. If I were to go to the random forest, all I need to do in the same syntax, I need to change it to forest train. So that is what I'm going to change it. Let's run it. Now recall that random forest is an improvement over the decision tree algorithm, wherein in decision tree there's just only one tree that gets created. In random forest, you actually end up creating a large number of trees. But the default settings are used here. Nevertheless, packages like Python or SAS or these cache action set, there are sub parameters also where if you want to change your number of trees, etc., you can always do that. So in random forest here, we have just run. Let's see some of the output. You see, by default, it has used 1,000 trees, and 1,000 trees, each of the tree would have predicted each row to be either a good or a bad or a defaulter or a non-defaulter. And then a voting would have ensued. So 1,000 trees will predict one single row, how it goes. The rest is, if okay, let me first scroll through the output of the random forest, basically summarizing where is the output cache table, and then of course the number of other settings and the total leaves that are there, and the other settings of max branch, min branch, confidence level for putting. Remember that you have a control on all these options. Of course, that becomes different subject altogether, that how to optimize the parameter or fine tune the hyperparameters, etc., etc. So let's not get into that. I'm just showcasing the capabilities here. So I'll go over there and then I'll go to the gradient boosting now. Same syntax, everything is same. Entry option is just I'm looking for 1,000 trees in gradient boosting. That is what is equal to 1,000 would mean. And then I would have the GB tree train going like this. The keyword is GB tree train, and I'm going to run that. You see, it has executed, and once again, you will get the similar kind of an output. 1,000 trees will run, and then what is the distribution, sampling rate, etc. The general parameters of gradient boosting. And the output cache tables, etc. And then we'll go to and do the similar thing with the neural network. So we're going to call the action set neural net, and then we'll call the ANN train action. So these are some of the actions that are available. It's a small package, but then it allows me to train an artificial neural network. That's the action available. ANN score will allow me to score that. ANN code, if I want a data step code, it can generate that as well. And that data step code could be deployed at any of the sites where you got some SAS available. And then it can be used for scoring over there itself. So you have that way. Then you have the application of this neural network. You see here some of the things that for the neural network. See, neural network is a layered architecture. It has got equations after equations that work in layers. And some of the items that you might see over here, for example, the table target input nominal, this syntax looks familiar, but then you have hidden is equal to 150. So hidden specifies the number of neurons for each hidden layer. For example, hidden 150 here specifies a hidden layer with 150 neurons. Then you have NL-opt. This specifies the non-linear optimization options. For example, you're using maximum iterations to be 100, convergence criteria, and you're using LGFS of optimization algorithm with the number of corrections applied as 6. Number of corrections, again, it specifies the number of corrections in the algorithm LBFGS update. The default is 20. So again, you have to provide certain number of corrections to this particular algorithm if you're using LBFS. There are other options also available. Just demonstrating this one. So I'm going to run this as well. So here my neural network runs. Again, the convergence status, target variable, number of nodes, etc. They are there, optimization history. Of course, neural network, once again, you won't be interested in looking at equations, and most softwares might not provide them because the number of parameters, if you have 150 neurons and you have got 12 inputs, even with one layer is 12 into 150, that many parameters. It's computationally intensive tool, lot of calculation, so we're not much interested. Now, once that is there, all the models are built now on the training data, but we're gonna score them onto the validation data. So that is very much possible within the same tool using these things. So all you need to do is to simply start calling in, for example, the action set A store. First, let's call in that. So what A store does is, if you have saved, for example, we have created models above, and I want to bring them in. A store is one of the method to bring them in for scoring purposes. So what you want to do is, you have created models using the training data. Now you want to run and score the validation data, and then you might want to assess based on the validation which model, how it performed, and hence and so forth. So what we are trying to do is to score the model, but to do that you have to call the model, and for calling the model back you have to use this package or action set, I would say A store, and that action set is called in. And you see that now, how do I score, for example, SVM? So I'm using con A store dot score, and then I'm calling in, and you see this time in the table the partition indicator is set equal to 0. So that's my validation data onto which what I'm doing the scoring. So I'm going to run that. So these are the timelines for the inner parts of the scoring. Now we are scoring different models. For example, here for regression, there's a different method. I have to restore the model. So I'm using logistic score action under the regression action set. So if it is there, you need to specify the table. You have to use the restore option to bring in your model that is created earlier and stored. And then you are just putting it out in another table. And likewise, you will see a similar syntax going in for scoring this one now, this encode name and assess one row. These are arguments that are required. Your encode name specifies whether encoding the variable names in the generated output table adds the target variable name to the predicted probability variable name, such as predicted probabilities for each response variable level. Now, it's a good idea to use this because you want to associate the target variable name along with your calculated or predicted probability values. So that way it becomes easier. So most of the SAS tools, they use this encode name property. Even if you were using some user interface tools in SAS, you would have actually used this encode name. And assess one row option here that you see, this one is, it sets the value to be true. So predicted probabilities are added to the results table for the event types. And all probabilities are included as separate columns and are used with the assess section. So since I'm going to use the assess section later on because I want to assess which of these models is the best, so I have to make this option as true. So likewise, now you see that your set of syntax, here it goes for the regression, then it goes for the decision tree, then it goes for the random forest model, and then it goes for the gradient boosting model, and then it goes for the neural network model. So all put together, I'm going to run that. So let it run for a while. It takes a little while here. Now I can check, I can view selected fields from the output object. So output cast tables, I'm going to go and I'm going to pick up the NN score object. I'm going to display that and I'm going to see the score info. So let's run this. So here how it is looking like. We have neural network score table available for us. It has that many rows, that is true. Validation rows were 1788 if you recall. And then this is how, the misclassification rate looks like. So around 8.5% misclassification, which is another way of saying that 1 minus of 8.5% would be 91.5% accuracy. Well, the next part is to, assess these models. So that is what, we'll be doing. Now for assessing the models, we have to create, some of these things. Ultimately, I have to have the models get predicted. I have to have the probability columns created. And once, the assessments are done, assessments will actually calculate some of the metrics percentile wise that I'm looking for. And once they are ready, I can create things like, ROC chart and all that. And then, we'll look at the output as well. Well, so to do that, what I'm going to do is let's first of all get back to the assess model part. So this is percentile wise data that I'm going to calculate, which will eventually help me to create percentile based assessment parameters. So there are a lot many of them. Even in your ROC chart or lift chart, you need to have percentile wise assessments done. So this syntax is pretty much doing that. Now let us see this output tables for NSS. Yeah, the tables are created, NSS and ROC. So these tables is the one that I might use the local capability also to, let's say I want to create a ROC chart, I can use now. So these two tables we have done, we have already viewed it. Again, I don't want to do, check this out. It's just the displaying of these tables, the first 5 rows. In case you wish to see, this is how it will look like. You have the column probability of being 1, you have different depths. So this is the different percentile depths I was talking about. Number of observation in each of them obviously would be the same, number of events would be different. And then you have the response percentages, etc. So this is how it looks like. Now based on this, you want to bring the results to the client. So I want to do now, if any of those ROC chart and anything else needs to be created, we want to bring the results to the client. Now here is where we now say that a lot of activities were done on CAS. We build models, we scored the models also on the CAS server. We ran the assess percentile wise, percentile wise assessment of the models. All that logic was run on CAS server. The tables were created on the CAS server, but now I want to use Python functionality to do the basic comparison charting and other things. So now let's check this out. So first of all, I want to bring all these tables. You see the usage of to_frame function. That is what allows me for each of the models. For example, I have a ROC table for logistic regression. I have a ROC table for support vector machine. I have ROC table for decision tree and hence for other algorithms like random forest and gradient boosting. Each of them is using to_frame function to bring the tables to the local. So what this does, it creates a series of local tables for me. Now, once these tables are there, I am actually free to do pretty much anything I like. For example, I want to compare, now this is all Python syntax. I'm using pandas data frame. I'm concatenating the data using pandas.concatenate function. I'm defining a variable cutoff index at 0.5, and then I'm going to compare the cutoff index with respect to the DFSS table, and here is my confusion matrix. So these are all the counts of true positive, false negative, and true negatives for all the models that are created. Now this thing is created by Python purely, because all the tables were brought to the client using to underscore frame function, and from there we just created this confusion matrix that is there. So that is how the whole story looks like. Of course, I've just created confusion matrix just to showcase. Now, once it is on the client side of it, and all these tables are with me, if I were to create ROC chart or any kind of lift chart, that can also be easily done, since I have all the power of Python graphics available with me through the matplotlib package. I'll showcase that capability as well. But for now, right now, I have the confusion matrix, and in the confusion matrix, you could see that we have true positive counts available. Looks like, and just I want to check out that the count is highest. If I look at where my TPs are high, my TPs are high with these two algorithms, the gradient boosting and the neural network. Likewise, correspondingly, the true negatives are also good as compared to the other models. But let us say this is the bad prediction. Remember the one or zero, you have two types of person in the target variable. Zero is bad, one is bad because the defaulter, and zero is good. So looking at one. And if your ones are getting predicted correctly, that model will be the better one. So usually here the gradient boosting and the neural network are pretty good as compared to obviously the other ones in the line. That's why I wanted to create that confusion matrix based comparison. So well, now what I will showcase is that once you have the data, you can actually create some of the other graphs as well. But as I said, after every hour or so, I'll take a stop for a while. And again, in case you have any queries and questions, please feel free to put them in the chat. Okay, guys, let's resume. Let me check. What do we have? Any questions? If they're there, let me address. So there are two questions. Let me address them one by one. So the first question goes like this: in the context of programming, how is this software can be relevant to product development, for example? Well, so please remember that the software that we're looking is Python plus SAS with SWAT package, SWAT package. This is not a product development tool. SAS is used for analytical modeling, data preparation, etc. So it's a data science tool. Product development happens separately with using separate tools. Those are usually Java, Lua, and few other technologies that are deployed for product development. This tool is definitely not any software product development, but it is application of data science and analytics. And that too in the context of what do you call machine learning here as we're looking at today. That is one. Products are also developed, UI based products are always available with SAS. So probably I will showcase it once, we actually, and this demonstration, I'll give you an overview of what kind of products at SAS we have. So those are once again all analytical based products. So all the SAS products would typically end up doing is to showcase how you can write code to perform either data wrangling or data curation or analytical modeling or machine learning, and then finally how to showcase the results. So that is what my answer to first question would be. So summarize in one line, it's not a product development tool at all. It is a data science tool for creating applications out of data science, like machine learning applications. Second question is requesting Python file and data sets for practice. Well, all these data sets, see, you can subscribe for something called as SAS via for learners, SAS VFL as we call it. And you can go in as a student if you have a college ID or as a learner. So there are multiple provisions for that, and that would have all these things. From the webinar standpoint, we're not sharing any of these items that are there. You might want to enroll for our courses for that. So I will give you an overview towards the end. So don't worry about it, how to actually get access to, let us say, the SAS tool or some of the demo data sets or the files, or what are the SAS resources that you might want to look into. There are free books available. A lot of these things are there. So I think I can spend some time towards the end for this as well. So that's great, guys. So let's check this out. Well, moving on. See, we were somewhere here before we said that let's move on, and I'll go full screen for a while. Let's come back and check this out. So we are looking for different things. I'm going to compare the misclassification rates now. So you see, compare misclassification, one minus, this is all Python syntax. Because we are on the local system now, we have brought in all the tables, and this is how the misclassification rates looks like. And you see the gradient boosting has the lowest one. And that's logical enough, because if you see in the earlier output, my TPs or true positive fractions for gradient boosting was highest, along with, TN were highest. Though of course neural network had 241, but here the TN was less for neural network. So obviously the misclassification rate for gradient boosting should be highest. So this is where these things go. So gradient boosting by far is the best modeling technique for this problem. Now I'm once again gonna pure Python features like PLT figure, PLT plot, models, or any other item that is there for creating my false positive rate and true positive rate. Remember that true positive rate is sensitivity, false positive rate is 1 minus specificity. All I'm looking at as the ROC curve. So this is my ROC curve for that. And obviously the highest area under the curve, look at the purple looking color over here, and that is gradient boosting, and that should have the highest convexity. In fact, let me make this also as full screen. Yeah, this makes sense a little better so that you can see the chart. So you have the true positive rate and you have the false positive rate over here. Now you might want to create lift curves. So once again, we are making references to each of the SS tables. We are using two frame function to bring everything to the local, and model wise, we are actually assessing the lift individually. And once all these columns are created, I'm going to use the pandas pd.concatenate function to actually connect all those tables into the system as one single DFSS table. Once it is done, I can actually plot these things, and it has to be y label has to be lift. Okay, let me just correct the code, guys, here, because it's using the previous. This should be depth. So usually in your lift chart, you have depth on the x-axis and you have lift on the top axis, sorry, the vertical axis and the horizontal axis, and you just want to see how the lift chart would look like. And here again, the gradient boosting should come up at the top if I run it. Yeah, so once again, the purple color is gradient boosting, and it is actually, ahead of all the curves that are there. So this is how you can create lift curves. Now, so what we have seen so far, if I were to look at all the items we have done, build all the models at the cache server, if you remember. And what we have done also is we have done all the assessments onto the cache server. But what we have done, all these graphs are being now built at the local Python level. So which means if you recall, when we started in the beginning, let me just take you over there. So any which ways, these were all my ROC charts. I was showing you the area under the curve and everything, and the lift chart. So higher the lift, the better is the model. So these were all the things we discussed. I just wanted to reach a typical slide here. So see what was all happening behind the scenes. If I were to now connect everything, see we had a client. So my client is this Jupyter notebook that you saw, Jupyter localhost, etc., etc. I'm connected to the Jupyter notebook, and we made a connection to the cache server. We checked the connection status, etc., everything. So that is what we did. Importing the packages, making connection to the cache. So the moment I was connected to the cache, I was connected to the controller. Remember, I'm going through a Jupyter notebook. I was connected to the controller and all the worker nodes. If you recall how many worker nodes I had, this was my cache session. This was a connected timeout setting is there. I went down. I brought in the data. I distributed the data. I had these 16 blocks, and these are details of the blocks. So I have these 16 worker nodes, wherein if you recall and remember, we also created this plot as well. How many rows of data for each of the blocks that is there. So this is what we did. We distributed the data onto each of the blocks that are there. And we used the local Python. We brought in the table. We created the chart. So I had 16 workers onto which my data was there. And I, of course, data loaded, brought in the CSV file. Now, we did a lot of calculations. Remember whether it was finding out simple frequencies or doing the count or missing value imputation or even running the models. All of it was actually done on the cache server. And remember, we are using Python through an API. We have the Jupyter notebook, and we were actually triggering and passing on commands to these cache or the cache actions that are there. So we actually got the benefit of in-memory processing. We process the data in the parallel. We saw examples of how we can access the same table copy. Remember that those access tables before making the graph, they were actually created on cache, but we created a copy onto the client server for getting those lift charts and ROC charts that we were talking about. So these were all the ones. So this is what we did. We used a lot of action sets. Remember that this was just an example, was shown the table and other things, but then we had a lot of them like the SVM or the regression or the decision tree, and we saw a lot of examples. And then, we ran all these things on cache server and we got the results. So we did heavy lifting on cache, like running the models and everything. And locally, what we did was we simply ran the simple graphs and the charts that are there. So that is what we did. And all we saw was the SWOT package. Remember that there are other packages like this that you might want to explore. So we ran all this. So that was just the slides that I am going through. So this was the best practice we followed. We let the cache to do the heavy lifting. All my neural network gradient boosting random forests were created here on the cloud, and the local results like the graphics was created. So all the charts and the tables that you see, they're locally created on Python, but all the heavy lifting calculations have been done on SAS via cache server. So that's a typical this. Now, let me also show you that all these examples that we took was more like using Python. Nevertheless, let me show you one thing. 11. See, pretty much the same thing could also be done using any other software. So let me see if I have, okay. So here I have, for example, the same example being done on R. So what I'm going to do is I'm not going to exactly run everything, but then I'll just show you that how the things would change if it was not Python, but if it was R. When it is R software, you see, my imports will get replaced by library. However, my cache actions will remain the same. So you see, I'm getting connection, and all the list sessions, etc. All these items are just the same. However, instead of read underscore CSV, I'm going to use cache.read.csv because this is what the function in R that will work using the SWOT package. But then few other things will always remain the same. So cache actions always remain the same, the block, the node level data, and other things. However, this time you see the usage of head function. In Python it is used separately, while for SWOT for R it is used separately. So what happens, a slight change in syntax depending on the language that you're looking into, and you could do everything based on R here. Whatever things needs to be done in R, specifically if you look at the plots, there you have a prominent Python package. Now let me show you how the package for, or let us say, remember the chart that we created? You see, we are using ggplot. Now, since the table is on the local thing, ggplot is the R library that helps you to plot. So if it were to be Python, it will become something else. If it is this histogram, blue, bins, etc. While if you recall, the Python code for the same item would be PLT, the short form of the package that we used. Let me take you there. This is how it looks like. So this is pure and pure Python, whereas this is pure and pure ggplot. So see, but my whole thing can be similar. What changes is when I shift from R to Python is just the syntax. So the open source as far as goes, whether it is R or Python, slight change of syntax, and you can still achieve pretty much everything that you've done, because ultimately the calculations are done by cache server. So irrespective of whether you actually push your command from R or push your command from Python, it hardly matters. So to say, if you recall this slide, I was just trying to explain, giving parallels for both R and Python. This slide, for example, irrespective of the fact whether you're using SAS software or Python software, or for example R, your cache action still remains the same. The SWOT package that is available with each of them would actually be working and doing the job for you. So that's typically the thing. So you have this package. Now there can be multiple examples for that. So let me show you. In fact, I could do pretty much using R or Python. SAS capabilities are great in the sense that I have just given you one of the demos, like machine learning demos. So you could pretty much do text mining if you wish to. You could perform time series analysis if you wish to. So if I'm just from the demo perspective, this is Python time series demo. So you're gonna have the timeline data. You're gonna same load the package, make the connection, and then load the table, and then plot the time. So let me just show you very quickly. Anyway, I'm already connected, but let me just reload this. Let me just establish the connection one more time. So if you're already connected and still you reconnect, the system simply connects it for you. This is the air passenger data. I will show you the data, how does it looks like. So let me load the data to the server. The file is now available. You want to see how, what is the shape and how the table looks like. So I'm just going to use the head function. So we have 326 rows and 4 columns. Basically a time series data, month wise and year. So you have month 1 of year 1980, 1990, and so onwards, and likewise several years worth of data and number of passengers traveling in that. And I want to see a plot, so I will use the Python PLT features. I'm going to show you show you how the now this is typically the passengers traveling from 1990 to 2017 airline passenger data. There should be a drop somewhere in 9/11 when happened, 150th month after 1990. Yeah, so around September 11, 2001. Yeah, so that was 9/11 when there was a sudden drop in passengers for a while. So this is my passengers data. Let me go full screen here. So now you see that irrespective of the technique or analysis, I have the capabilities over here. So I want till 2012, I want to keep it as training data, and the other one I want to keep validation data. So data partitioning happening. Let me do that. So see, this is the data step. Now, every time I want to run a data step in SAS, I'm going to use a different action and action set for that. So here we are. I'm going to build the model. Now you see, I'm going to use time data.forecast. So time data is the action set and forecast is the action. And I'm going to run that. And I'm going to run it. You see the models have been tried, Winter's model and ARIMA X model. Now these are all forecasting techniques. If you're wondering what are these are forecasting models that are tried. In fact, it make a lot of sense if I analyze my forecast through a local system using Python. So you see the ARIMA algorithm and the Winter's algorithm was applied by cache server. That is the heavy duty work that has been done by the SAS. However, locally I could do the things using Python, for example, plotting my figures and plotting my data. So I'm going to run this. So these are how see the red ones is the model that has been fit. Blue one is the observed, and this blue is the forecasted ones. So this is the horizon or the timeline that we have, and the remaining is the forecast that gets generated. So forecast seems to be actually following and mimicking uh, the patterns that exist in the data. Now these are usual patterns. Remember that in the airline data, using the winter vacation or the summer vacation, the number of passengers traveling would go up while they would be down, or while when you have busy hours on the day. So you could actually create these things. And if you want confidence levels also, once again here all PLT plot, title, X label, Y label, all the syntax that you're seeing is Python based. So you have your forecast generated, you have the confidence intervals, and you have the forecast that are there. This is a 5-year forecast for the number of passengers traveling through the airlines. So these are all, the different examples that you could use. So any kind of a data science problem that you have, whether it is forecasting, we saw whether it is modeling or machine learning, they all could be deployed through a Jupyter notebook, while all the calculations happen on cache server, and few local things like plotting of graphs and charting, etc., could be done using your local Python or local R software. That's the pretty much integration part. Now, coming to a few other things, for example, when we talk about integration, see, we need not necessarily use this Jupyter notebook. Let me take you there. So I might not have the demos for everything, but let me just show you what are the other possibilities that are there. So for example, I'm going to show you SAS drive. See, SAS drive, as I said, this is our, remember when I was explaining cache server, you have UI based tool also. So you want to manage data, prepare data, explore and visualize, build models, manage models, etc. All are there. You want to develop SAS code, you could do that. For your streaming analytics, you have all the possibilities over there, like design streaming projects, manage streaming analytics, visualize event streams, etc. Again, for administration, etc. Now this is a tool that is there, and different tools at different points of time. Let me just show you build models, which is our UI based tool. And it would also have provision that you could want to add something as an open source basis to a project. So I will just actually, okay, let me just open up a project. Now here, no coding, you all have to do is to simply point and click and create your models. So a typical pipeline would eventually would look something like this. So you are actually having the data, you are imputing missing values, you are putting logistic regression, you have a neural network node. Everything here also happens on cache. So when you run it, the entire processing of any of these neural networks or logistic regression and other items are all happening on a cache server. But then here you are all doing dragging and dropping. Even here in this setup, if I look at the nodes that are available, you see you have open source code node over there. All you have to do is to drag it. Let us say you want to put it after the impute node. That becomes the part of your tool. You can actually directly also connect it with other. Now you want to add Python code, you can run Python or R code. So these are all different Python variables that are supported. Only thing, you need to have the Python code for that, what actually you want to do. But my intention of showcasing this is that you can plug in your open source code anywhere between the process of pipeline based machine learning, and you can take the advantage of any open source model if you have built earlier, or you believe that it's your innovative idea should be the part of the pipeline. This all can also be added here in Model Studio as well. So that is what typically the SAS Model Studio is all about. It's basically making rapid models using a pipeline approach, using a drag and drop approach, comparing the models, etc., everything. And then within that, you could have, now remember that it has everything. For example, for supervised learning, it has everything starting from Bayesian network to decision tree to GLM to logistic regression. But the focus is not talking about this tool. Only the thing that I wanted to show that several tools like this in SAS would have one way or one provision or the other to bring in the open source code inside of it. Similarly, in SAS Studio, let me show you the SAS Studio as well. SAS Studio is SAS native programming interface. Let me open the SAS Studio, and there also, you could actually use proc Python to actually write your code. For example, you can still say I want to write a SAS program, but you could start with proc Python. Or let me type proc Python. And here you can provide, the logic for the Python that you want to run. And towards the end, you have to quit and run the code, etc. In between, you want to define Python function, write Python function. This is the place where you will be doing. So here is, the second place that you have got. I mean, the third place. So one was the Jupyter Notebook and all. The second I showed you was the Model Studio, and here you have SAS Studio where you could use a procedure like Python, and between it, whatever is required, you could actually do that. So these are all the other places where you might want to explore and see where else the open source integration can happen with SAS. Nevertheless, we have lot of resources that might want you to help you. So I'll give you a glimpse of all those resources before we go. But let me first explore my Q&A, and then if there are any question and answers that needs to be tackled, I'll tackle them, and then I'll come back. Okay, now we have one of the questions in the chat. Being an open source, is this free? Okay, great. So let us check this out. See, what is free and what is not free? Let us check this out, because this question needs to be answered in the context. See, SAS is not a free software. So all these products that you see, whether it is SAS Studio, whether it is, for example, Model Studio, or any of the CAS related products, the cloud analytical services, it all comes with the license. So it's not free. However, what is free is the packages which you can bring in. For example, the SWOT package of Python we were talking about, or for R, the SWOT package, and other packages like DLPY, SASPY, SAS opt. So all these packages. So let me just show you what I mean to say. Some of the packages that we were talking about, and I'll just show you the resources. So these packages like SAS opt py, DLPy, ESPy, SASPy, they're kind of free and you can download. There are all links available. I will just show you where it is. Only problem is they will only execute on a CAS server. So you must be connected to a CAS server to get to them. And for CAS server, you might want to pay. But you need to have a license of CAS. So remember, SAS is not open source free. What we're telling is that open source languages like Python and R, you can connect with SAS and get your work done. So the whole idea is you're a SAS client, you have now teams or companies which are acquired or merged. They have a lot of R and Python code that won't go waste. You can simply integrate your R and Python hard work, innovation, and integrate well into your SAS environment. So that's where all these things do. Nevertheless, let me just show you a few things. See, there are resources that you might want to explore. So I will be putting them in the chat also. First of all, the CAS action sets we have been talking about, the syntax of that. We have SAS Help Center. The product documentation. So there are different action sets, and there are a lot of them. So all these action sets, I mean, the documentation, you want to see how to use a decision tree action set or CDM or any other thing. I mean, there's a long list of action sets that is there that's available on this link. I'll be putting these links in the chat. So some of the documentations, that you want to explore, you can. So that is one way to look at it. If you want to look at SAS packages, let's say SAS packages like SWOT, SAS Opti. You can actually get a lot of information. First of all, these packages are available on the GitHub. We have SAS communities which you might want to join because a lot of this information is available around these packages. We have nice articles coming in. You want to look for and read for that, so please go through it. I will share the link for that as well. SAS communities. Now these are free to join communities. You just want to be the member over there. And then you can get more information about these packages that there. What are these packages, what they're doing, where those packages are available, and what do they do. So details are also available. So I want you to check this out. Different types of packages that are available. We have this GitHub link. For example, let me just go over there. You might want to check for all these packages. As I said, all these packages are free in the sense that you can explore them, check them. Only thing, while executing, you need to have appropriate license there. So let me put that link as well. So these are all the links you might want to explore. Whereas we have videos on SAS and open source integration. Let me share some of the resources. First of all, you have some common links like this. Plus, I want to also share the video library. We have a video library where you got a lot of videos. So we have got SAS video portal. We got links like, for example, executing open source code in machine learning pipelines. I want to check that out. So I'll just share one link and that will take you over there. Let me share the link with you.
My name is Radhika Maineni and I work in data mining and machine learning R&D at SAS. In this video, we are going to look at how to execute open source code, specifically Python and R, in SAS visual data mining and machine learning pipelines. SAS visual data mining and machine learning encompasses many tools, including those for data preparation, interactive model building, defining modeling flows with pipelines, managing and deploying models, etc. Model Studio is a component of SAS visual data mining and machine learning that aids in defining and automating modeling with pipelines. It includes nodes that can be added to pipeline flows for building various models and eventually comparing them to pick the best model. The open source code node is new in Model Studio 8.3 and will be available in July 2018. It supports the Python and R languages and requires them and any necessary packages to be installed on the SAS compute server, which is the engine that runs SAS code. The open source code node downloads a data sample from the SAS Cloud Analytics Server, also known as CAS, to the compute server during execution. This data transfer happens with comma-separated value or CSV files. The user can choose to work with CSV files, but for convenience, the node also makes these data available as a data frame. Let's start by describing the setup steps for the open source code node. As I've already mentioned, Python and R have to be installed on the compute server. The node itself is agnostic to the version of the Python or R installed. That is, any version can be used as long as the code written in the node editor matches the installed version of the software. I mention this because the syntax for Python 2 and Python 3 is slightly different and sometimes not interchangeable. To make the node accessible to all users, Python and R should be installed with administrator privileges, and the directories where the executables Python and R script reside should be placed in the system path. On Windows, the system environment variables Python home and R home can be defined as an alternative to point to these executables. Now let's get into the node details. The open source code node is located in the miscellaneous group as shown, right above the SAS code node. You can place this node in the preprocessing group as shown in the leftmost flow, or you can move it to the supervised learning group as shown on the right. When you have modeling node that trains and makes predictions, you should move the node to supervised learning. We will get into those details in a little bit, but first let's talk about the node properties. In the open source code node, you can choose Python and or R by using the language property. Use the data sample group of properties to select how much input data and what kind of sample needs to be downloaded when you execute this node. Getting into the details, the data sample is downloaded as a CSV file from SAS. Remember, Python and R are installed on the compute server, so data has to move from SAS to the compute server for the node to do its work. So be sure to use caution and avoid moving large amounts of data. By default, a stratified sample of 10,000 observations is created based on the partition variable and the class target when applicable. Be aware that the open source code node is working off a sample here. This would become important aspect to consider if you choose to compare this node with other modeling nodes in the pipeline that use full data. Use the Open button in the node properties to access the code editor, where you can type in Python or R code. As you can see, the code editor has a fair amount of context highlighting for readability. The variables that you see on the left-hand side are created by the precursor code. You can hover over the mouse pointer over them to see their descriptions. So what is this precursor code? During node execution, various code snippets are generated and put together before and after the user code as shown in this slide. What snippets get added somewhat depend on the node properties. So why are these code snippets needed? The simple answer is for convenience. Let me show you an example. This is the first part of the precursor code. You can see a sample both in Python and in R. It defines variables like dm_nodedir, which represents the transient working directory of the node during execution. dm_dec_target has the name of the target variable. dm_class_input contains a list of categorical variables in your data. As you can see, these are convenience variables that you can use while coding in Python or R. The node properties include a generate data frame property that is selected by default. When this property is selected, the second part of the precursor code is added. What this code is doing is converting the downloaded CSV input data to an R data frame or a pandas data frame in Python. Again, this is for convenience. In R, all the categorical variables are also converted to factors as part of this step. The posterior code snippet, as the name implies, is added after the user code and converts the data frame containing predictions back to CSV so they can be uploaded into SAS for model assessment. What I mean by model assessment is the computation of model fit statistics like misclassification rate for binary or nominal targets or mean square error for interval targets. So in summary, when you run the node, the actual code that is executed is a combination of the precursor code, the code entered by the user in the code editor, and the posterior code. Now let's look at the node results. After the node executes successfully, you can view them by right-clicking the node and selecting results. In the R example shown here, 2 output files are generated after a random forest model is trained. The rpt_forest MSE plot file is a PNG or image file that plots the mean square error during training, and the rpt_forest imp.csv file contains variable importance in a CSV or tabular format. After successful execution, they show up like this in the node results. There are 2 reasons why the output from Python or R execution can be viewed in the node. First, output file name should be saved with an rpt_prefix because this tells the node to display them in results. And second, the file extension has to be CSV, TXT, PNG, JPEG or GIF because this tells the node how to display them. CSV files are displayed as tables, TXT files are displayed as plain text, and PNG, JPEG and GIF files are displayed as images. Now, let's look at what it means to move the open source code node to supervised learning. To reiterate, the open source code node can be executed in the pre-processing group or supervised learning group. What that means is that you can do pre-processing work in this node or you can build supervised models. Typically, you move this node to supervised learning to perform model assessment and model comparison with other modeling nodes in the pipeline. For this to happen, you need to ensure that model predictions are saved in the dm_score_df data frame if the generate data frame property is enabled, or in the node_score.csv file if generate data frame is disabled. In addition, the prediction variables in this data frame or CSV should follow a naming convention. When the target is interval, the prediction variable should be named p_target variable name, and when the target is categorical, the posterior probabilities for every level of the target should be generated with the naming convention p_target variable name followed by the corresponding target level. For example, if you have a binary target variable called bad with levels 0 and 1, the variable names of the posterior probabilities should be p_bad0 or p_bad1 respectively. When the open source code node is in supervised learning and prediction data and variables are named as mentioned in the previous slide, then you should see additional charts in the node results and perform model assessment. These charts include lift, fit statistics, ROC for binary target, etc. In supervised learning, the node also performs model comparison. That is, you can compare Python or R models with other modeling nodes in the pipeline. There is one point I want to emphasize here. If your data are big, the open source code node will download a sample and train by using that sample, while other nodes will train on the complete data. In this scenario, if you are comparing models, you need to be aware that the number of observations in the validation data used for comparison might be different for the open source model compared to the other models in the pipeline. In summary, the open source code node supports both Python and R languages. It can display results, it can produce assessment statistics, and enable you to compare your model with other models in the pipeline. What the open source code node cannot do is be part of an ensemble. It cannot support registering to a database, publishing to Model Manager, or the ability to download scoring code or scoring APIs. This is
well guys, so I think these are all the things that you might want to check out and see. And there's a question in the chat, how to get the recording of today's webinar. So probably, the link will reach you. over the registered email that you might have given. I need to know from my team by when the recording links will be shared. So probably Dev Prakash might want to answer it. Yeah, guys, by tomorrow you should be getting this recording link. So guys, before we close, I think we got a poll here. If you want to actually start with the poll, that would be a good idea. We have few minutes left, so this time please feel free. You can actually raise questions, ask questions. Let's utilize few minutes that are there. Plus we have a poll also, so let me launch the poll. Please check this out, and let me provide you with the poll. Hopefully the poll is up. I believe so. It is yes. So please try answering the poll, and once you're done, we'll close. In the same time, please feel free to ask any other questions that are there. And in the meantime, let me thank all of you for attending. Side by side, these are people, if you are connected from different parts of the world, and if you want to know more about any of these things, we have these contacts in India, Australia, Philippines, Thailand, Malaysia, and Hong Kong. Just please make a note of these email IDs if you wish to. Maybe I'll put them in the chat in case you're interested. Let me see if they go in the chat very well. So these are all the contact IDs from different countries. I don't know whether I'll be able to copy them in the chat. I don't think it will work. So these are all the people whom you want to connect. If you want to know more about any of the SAS related trainings, education, opportunities, please feel free to do so. While this happens, let me also formally thank you. So guys, thank you once again for getting connected. You have this email ID in case you want to get connected to the people, or else, if you want to get connected, you have these links available across the countries in your respective country. If you want to touch base with the people, you can be in touch with all these people. Just have a connect with them. We have people across the Asia Pacific region here: India, Australia, Philippines, Thailand, Malaysia, Hong Kong. Please check this out. Plus, these are some of the links. I've already shared them on the chat. You please have a look into them. And once again, thank you for all. And we will be closing the session in a minute.